Hello, hello, my dear friends. Oh, hello, anyone is in live? If anyone is in live, just text a I over there in the chat box. Hello. Now, in the last class, we have studied up to where? Up to the chemical properties of the alkenes. Now, what are the very important chemical properties of the alkenes? We have seen Markownikoff rule, anti-Markownikoff rule, and the addition of H2O, and the oxymercuration, demercuration, and which one? Hydroboration. Then after that, Bayer's reagent, and based on that we have did the some PYQs also. Clear? Now here we are going to see today today's class we are going to see the what preparations of the alkyne. Then once the preparations of the alkynes has been done, then we are going to see the which one. Next we are going to see the aromatic hydrocarbons. Then after the aromatic hydrocarbons followed by questions we are going to see, because now first chapter we have did the which one, alkenes. Then after that the questions we have did, then after that alkenes. Clear? Then this all we have did. Now here right now meanwhile what we'll do, will hi Ra Pranit, hi. Now just we will wait for the 2 minutes, and we will start the class, because let others to join. Now in the last class we have studied up to alkanes, right? Done. Now in the last class we have studied up to the how the Bayer's reagent will react, and we have did the some questions on that. Clear? Now symmetrical cis upon cis addition, symmetrical trans upon trans addition, that we have studied. Done. Now right, should I recap the last class? Should I recap the last class what we have studied? Should I recap, or shall we start the alkynes once? ఒకసారి that alkenes ఒకసారి recap చేయనా, chemical properties of the alkenes, or directly we'll start the alkynes? If you want me to recap the last class once, I will recap, so that whatever the concept that we have studied, that it will be what? It will be connectivity for this class. Okay, now better I will quick recap the which one, last class what we have studied from the which one, from chemical properties of the alkenes. Done. Now alright, from here now I will quickly recap the lecture here. Here first, alkynes will readily show the which one, electrophilic addition reaction, that we know. Clear? Why it will show the electrophilic addition reaction? Because alkene itself the nucleophile, because it will not attack the nucleophile very fastly. Then now just I will minimize my 1 minute. Done. Right. Now here the alkene itself the nucleophile. Now alkene itself the nucleophile, right? That's the reason it will not attack the nucleophile first. Then the alkene will readily attack the electrophile first and it will show the electrophilic addition reaction. Done. Next here in this electrophilic addition reaction, first this alkene pi bond will abstract the which one? Electrophile. Now that is a rate determining step. Now then after that here this carbon will get the what? Positive charge, and when this carbon get the positive charge and this nucleophile will go and attack to that carbon in which position? Here we are having the two chances. One, it can be attacked from the opposite end to the electrophile, then that addition we call it as an anti-addition. If the same to the electrophile and that type of the addition we call it as a syn addition. Done. Now next we have seen. Now what are the key points that electrophilic addition it will readily undergo? So in the electrophilic key points of the electrophilic addition reaction, first is carbocation intermediate, then after that rearrangement is possible, then after the formation of the carbocation is a rate determining step, then the rate of the nucleophile is directly proportional to the alkene, then it is directly proportional to the electron donating groups containing alkene, then after the stability of the carbocation, this we have seen yesterday. Then here the carbocation or alkene will readily undergo two types of the electrophilic addition reaction. One with the classical carbocation. When the classical carbocation it will readily undergo? Because when it is having, when the electrophile does not contain any lone pair of electron, then it will readily undergo classical carbocation mechanism. Done. Clear? Now if suppose here non-classical carbocation, how it will be readily undergo? Non-classical carbocation it will be readily undergo when it is having the lone pair of electrons. If the electrophile, if it is having the lone pair of electrons, then it will readily undergo non-classical carbocation. Now what are the example? One is the X plus and the OH plus, because oxygen it is having the lone pair of electron. Then after that NO plus, then after the Hg plus 2. These are the some electrophiles that we have seen. Now what are the key points we have to remember? Now electrophile atom must contain the lone pair of electrons. What? To show the which reaction? To show what? Non-classical carbocation reaction to undergo. What it should be there? It should be there electrophile on it. Then after that this carbocation bridged is the intermediate in that. Next after that rearrangement is not possible. This is a key step when the which one? Alkene is following the non-classical carbocation. Non-classical carbocation if it is following, then the rearrangement is not possible over there. Clear? Done. Next. Then here the Tilden's reagent, this one we call it as a Tilden's reagent. Ayush, hi Ayush. Good evening Ayush. Now here next what we have seen? Now we have seen the how the HX will be added to the alkene. Now in the HX, because we know the alkene itself the nucleophile, that alkene when it is behaving as a nucleophile, it will readily, what it will do? It will readily abstract the proton first. Clear? Then when it has abstracted the H plus, then after that this carbocation will get the, sir, how to start the organic now for JEE 2026? Start the organic from the GOC. Okay, GOC and hydrocarbons. GOC and the hydrocarbons. Is it possible? Yes. If you start the organic If you want to start the organic, start from the GOC. Before starting the GOC, yes, already I was guided. Already, what are the basics to start the organic chemistry? Already I did the lectures. It is already I was uploaded in my YouTube channel. Once you can go and cross check. Before starting the organic, what are the basics to understand? Clear? If that basics are clear for you, now organic chemistry will not be problem for you. That already I explained very clearly. Now what are the basics to start? Clear? Now what are the concepts to clear for us to start the organic chemistry? That already I did. Once you cross check the videos which are there in my YouTube channel. Okay? Is it possible? First, you have to clear with the hybridization. You have to clear with the conjugate acid and the conjugate bases. Done. Now, electronegativity and size, electrophile, nucleophile, IUPAC. These are the some basics will play very crucial role to get more success in the organic chemistry. That's what I am saying. First, if you are cleared with the basics of the GOC and hydrocarbons, then hydrocarbons, whatever the reactions that we are going to study in the hydrocarbons, that basics, that applications of the that hydrocarbons basics only we are going to see in the different chapter, that alkyne alurins. We have to take the one hydrocarbon reaction and we have to study in the alkyne alurins, and we have to take the one hydrocarbon reaction and we have to study in the what alcohols, phenols, ethers. We have to take the one hydrocarbon reaction and we have to study in the which one we have to study in the carbonyl compounds. Clear? In that manner. Then after that, all the chapters conversions we have to study, because the conversions I am saying, you know, conversion questions more you will be get perfect when all the organic chapters has been done. Conversion questions initially it will make you tough. Initially it will make you tough because different reagents it will come. So that's the reason, once if the organic, all the chapters of the organic chemistry has been done, then the conversion questions and the reaction questions will be very useful for you, or very easy for you. Within the fraction of seconds, if you are practicing the n number of questions daily, within the fraction of seconds you can do the question. That is very easy. But first try to build up the basics. Basics will play very crucial role. Then after that, after the basics clear, then you can start the chapter. Clear? That's what I am saying you, that conversions will play a very crucial role. That conversion questions, why it will play very crucial role and why you are facing the difficulty, I know. Because here hydrocarbons, whatever the reactions we are studying, that hydrocarbons reaction, alkyne alurin reaction and the alcohols phenols reaction, they will combinedly they will ask initially. That's what I am saying, you know. Try to do the conversion questions by your own. I will say, that's what I am saying you. Here my motto is that first of all, what are the basics required to start the organic chemistry? Already I did the very beautiful lectures in my YouTube channel. Once you cross check, then after that I started the GOC. First I started the IUPAC, then after that I came to the GOC. Now I came to the hydrocarbons. Done. Once this, next I will start the isomerism. Then once if these lectures, if it is completed, then I can start the conversion questions. Once the organic chemistry total it is done, then one by one I can do the conversions, so that it will be easy. Without knowing anything, once if I start the conversion questions, you may feel difficulty. So that's the reason I was saying you, what? First let's try to finish all the chapters of the organic chemistry, because one chapter conversions will not be very easy, because we have to do the conversion questions of all the chapters. If the conversion, if they ask of the alkynes, or if you have studied the hydrocarbons and if you have not studied the alloalkanes and the alloarenes, then you cannot do that one. So that's the reason first let me finish the all the chapters. Done. Now the next type of the addition of the HX. Okay, clear. Now if you are Ayush, if you are facing any problem, you can text me to the my mail. I was mentioned in my description, as well as in the videos descriptions also I was mentioned. If you are facing that is only interconnected, that only that's what I'm saying. One chapter, how the interconversions will play very crucial role. I will do the n number of questions in the organic chemistry. Once the concept is clear, now doing the n number of questions, it will make you strengthen. That I will do. N number of the questions I will do, and I will bring, and I will do daily live session, so that the organic chemistry will become easy for you. Okay, my motto is to make the organic chemistry easy for the students. For that one, first of all, GOC and hydrocarbon IUPAC, this concept they have to strengthen first. If these concepts are strengthened by any student, they will never and ever they will face any problem in the organic chemistry. Hello, game changer. Hello, may I know your name? Can one shot help? Nana, one shot will actually if all the chapters, what I'm saying, if all the chapters concepts are clear, then the one shot will be help. If all the chapters, I am saying, all the chapters, if you have done, you are in the that much stage to do any questions. For the revision case, one shot will be help. Actually, organic chemistry you will never and ever get by the one shot. That organic chemistry is not like the one day batting one. Organic chemistry is the daily practicing. Daily you have to do. Daily more the questions if you do, more you will get. My dear friends, about the organic chemistry, as a faculty, I was explaining you very clearly. Listen. Once if you listen the concept, very fastly you can do the questions, because already at that time, that's what I'm saying you. Listen here, once if you listen to any concept, and if I ask the questions based on it, many of the students they can do, because why, already you have learned that concept, so the concept is in your mind. Then whatever the questions as a faculty he has asked over there, directly you can answer, and you will feel that, oh, I know the organic chemistry. And you will feel that I know the organic chemistry. Then after, what it will happen? No, once if you shift to the any physics, and once if you shift to the maths, and then once again you open that same reaction, again you will feel the difficulty over there. Why this has happened over there? So that's the reason daily daily I will do the lectures from today, already since from the 4 days, daily around 8:30 I will post in the every day 8:30 to 9. In between 8:30 to 9 I will start the live every day 8:30 to 9, or else you can text me to my mail ID. Actually, this is the public platform, right? I cannot provide my personal number. You can text me to my mail. I was providing my mail here, so that I can personally I can guide you, and I will intimate you when my live is going to start. Now this is my mail ID I was given to you. You can text me over there, so that when the live starts I can give the information for you. Okay, now is there any doubts? Ayush, sir, should I start the class? Exact time every day 8:30 to 9. I mean exact time, because here this is the rainy seasons, right? Because if sometimes if the rain comes, like the current issue, it will be there. So based on that, I may start 8:30 or 9. Most of the cases I will start at 9 only. Most of the cases I will start the 9. And the Sunday, every Sunday, that entire organic chemistry what we have studied, that from the concept, from the basics to conversion, high level of the questions session will be there on the Sunday. On every Sunday the session will be. Ayush, may I know from where are you from, and which standard you are? Like you are in the class 11th or class 12th, or repeater? Nine to that we don't know until what time it will go. It is depend upon the students, like their ability. If you are having a zeal to study, I am having a zeal to teach. If you are having a zeal to study up to the 2 or night up to the morning, I am having a zeal to teach. My motto is to be make your life easy in the organic chemistry. I can teach up to 11 hours, 12 hours. Okay, that is not a big issue for me. If you are a zeal and if you are able to study, I am ready to teach. I will not cross check any time, whether it is a 9 hours or 5 hours or 6 hours. I can teach, but ending time I cannot say. I will make you master in chemistry if you follow the daily guidance and the daily lectures of mine. I will make you. But before starting the GOC, try to strengthen what are the basics it required to start the GOC. Organic chemistry to start, some basics are required. If it is clear for you, then you will become the master in chemistry and as well as organic also. Okay, you are in the 12th JEE. Okay, fine, good. May I know you are from? Where are you from, Ayush? Now, here, now we'll start the lecture. Here, in the addition of HX, one H nucleophile will be attacked to the H plus, and the X minus nucleophile will go and attack to the carbon that we have seen. Then in that this Maharashtra. Okay, good, fine. Now, okay, follow the lectures daily, and if any lectures if you have missed, you can text me over there. Already I was provided my mail to you. Clear? Then after that, whatever the doubts you are having, okay, now listen. Now, next, this Markownikoff rule, whatever we are going to study, this application part of the Markownikoff rule is very important, and in our entire organic chemistry, this Markownikoff rule we are going to place. Clear? Namaste, strict namaste. Clear? Now good evening. Now listen to the class. Now we'll start the lecture, because the Markownikoff rule will be applicable for the which one? Unsymmetrical alkenes only. Clear? In the unsymmetrical alkenes, then after that the negative part of attacking reagents will go and add to the carbon which contain less number of hydrogens. Clear? Now the Ayush, I will make you help you to solve the advanced level questions of the organic also. Okay, try to follow the lectures, and what are the guidance I was giving to you, just you follow. I will make you, that I can assure you. Then the negative part of the attacking reagent will go and attack to the, sir, for Monday test, is it the full GOC or half? No, full GOC as well as the full hydrocarbons. Full GOC and the full hydrocarbons. IUPAC, isomerism, GOC, and the next hydrocarbon alkanes, alkenes, alkynes, as well as the aromatic hydrocarbons. Complete are there. Now, clear, the negative part of the attacking reagent will go and attack to the carbon which contain less number of the hydrogens. Now, these are the very two key points we have to remember for the Markownikoff rule. Then here they will ask you which among those two the Markownikoff rule will be happened, because this is a symmetrical, Markownikoff rule will not be happen. Now this is a asymmetrical, Markownikoff rule will be happen. Okay, done. Now try to listen to the class also, so that in between revision plus the questions also I will do, because I brought the n number of questions. Clear? Done. Next, clear? Now we'll see here, whenever the asymmetrical alkene if they are given, clear, then here the asymmetrical, no, I'm not the, I was from Hyderabad, Space Prince, no, I was from Hyderabad, Telugu, no, Telugu, I was from Telugu, I was from Hyderabad and I was Telangana guy. My dear friends, if your doubts and everything, if it is completed, I will start the lecture. If not, if any doubts, if you are having, you can clarify so that I can start the lecture. Already I was, okay, done. Now if you are having any doubts and anything, okay, Elaya, good. Elaya Neelam, good Nana, good. Okay, fine. Elaya, from where, like which class you are studying? At ekkada? A class, JEE prepare aitunnava, NEET ka? Are you preparing for JEE or NEET? My dear friends, the who are in the online or who are in the live, whatever the doubts if you are having, once you clear whatever the doubts you are having, so that I will clarify all your doubts among your academics and everything, among the organic, among the chemistry, among the JEE, for the JEE and for the NEET. After that, once if your doubts are clear, then I will start the, okay, good. These classes will be helpful for you, the NEET long term also. Okay, Nana. Everyone, the one who are in the live, all the doubts are clear, right, for you? Should I start the lecture? In lecture start చేయమంటే స్టార్ట్ చేస్తా. తెలుగులో టీచ్ చేయన్నా, తెలుగులో టీచ్ చేస్తా. క్లియర్? Because some other students are also coming from other states, right? So మధ్యలో తెలుగు వస్తుంది, మధ్యలో తెలుగు మాట్లాడతాను. అమ్మా, if you want my qualification is MSc chemistry from the Usmania University from the Telangana. Okay, then about the, and I was worked in the very big reputed institutions of our India. Clear? I hope all the doubts are clear, I think so. Then now I am going to start the class. If any doubts if you are having, just clarify it. It's already, the class has been started when When it has started? Already it has started half an hour back. Now we are going to start the class with the alkynes. Already yesterday we have cleared very clearly. I was explained the which one. Yes, I was completed the my MSc chemistry from the Usmania University, main university. Now, is there any doubts still? Still any doubts you are having? Now, I am starting the lecture with the alkynes. Now, yesterday we have cleared with the which one? Now, in the alkynes. Done? Hello Suhas, correct time ko వచ్చినావు. Correct time ko వచ్చినావు class start చేసే time ki. Now, general formula or general name of the alkynes is acetylene. General name of the alkynes is acetylene, and the general formula of the alkynes is CnH2n minus 2. Done. And the sir, aim doubt amma, what is your doubt? Which of the following alkane will give you the racemic mixture on the reaction with HBr? No peroxide. Which of the following alkene will give you a racemic mixture on reaction with HBr? It is not clear. CH2 racemic mixture, CH3 C double bond symmetrical, no peroxide. C adi. CH2, this is CH3. Yeah, it will give. Good. Which of the following alkenes will give you the racemic mixture on the reaction with the HBr? No peroxide. That A. A it will give. A it will give. Clear? Now, next hybridization is the sp, then the functional group is C triple bond C, then the bond length C triple bond C bond length is 1.20 angstroms. Now we'll start the preparations of the alkynes. In the preparations of the alkynes, your alkene addition you are saying, right? With the no peroxide, it is Cl. These options are not clear for me here. First one is the prop 1 in. And the HBr. Now first one will give you the Br here. Done. And here it is the hydrogen. And the option B is here. HBr symmetrically. One either Br we can add anywhere. Then C is C. How come that C? How the carbon valence C for the C is not fixed? This is alkene, and here it is a CH. That carbon it is having CH3 or CH3. It is appearing very low, Nana. Here it is CH3. Then here it is a HBr. Here the Br will be added. That is only right. Option C. CH2 double bond CH3 and CH3. CH2 double bond on CH3 on CH3. Here it is not there. CH3. Okay. CH2. Okay, fine. Here it is not there. Then option D for you. Option D, that is CH2Cl. CH3 CH. This is Cl. Okay. Here the Br, and here it is a Cl, and here it is a hydrogen. Here what is asking? This is D. Here if it is do the atomic mixture, here the Cl. This is the one chiral carbon. Now you say me, which of the following alkene gives the racemic mixture with the HBr, no peroxide? Here this racemic mixture, here all are sp2 carbons only. This is multi-correct or single correct? That option is not clear for me. It is. This is the product it will give. If the option D CH3 CH double bond Cl. Now what you are saying? The following alkenes racemic mixture. Give a racemic mixture single. Okay, done. And this is the product it will give. HBr. HBr. It will give the product here. Here the Br. Here it is a Cl, and here it is a H. That what I am saying. This is the product it will give. This is the product it will give. Here the carbocation is unstable because already here the Cl it is there. Okay, now this is the product it will give. Now you can cross check over there. Now we'll start the lecture. Now in the preparation of alkynes, see with all the options I explained very clearly what are the products it will get. What are the products it will get with all the options, whatever you have given to me, that I explained. I added the HBr to that given alkene. HBr addition with no peroxide, it will follow the which one? Markownikoff rule. Or substitution. Yes, that only I wrote, but here this is, you can see here the carbocation is unstable due to the presence of this electron withdrawing group. Due to the presence of this electron withdrawing group, here the what? Br will not, sorry, Br will come here. Oh, sorry. Here the Br will come, here the hydrogen will come. Done. Here the Br will come, because here the Br will not be stable. Here the Br is stable. Here the hydrogen will come. Done. Clear? Now this is the product. This is the product for the D option, whatever you have asked. Here the carbanion is stable due to the presence of this electron withdrawing group. Done? No. Yes, that's what I am saying you. Here the positive charge, if it is there, this is sp2 carbon, sp2 carbon is planar. sp2 carbon is planar. sp2 carbon, if it is planar, attack came from the above end, attack came from the below end to give the racemic mixture product. if any sp2 carbon or carbocation, if it is generated, either the nucleophile can be attacked from the above end, either it can be attacked from the below end. Is it clear? Still you are having any doubts? Strict. Still if you are having any doubts, let me clear the doubts. Still if you are having any doubts, clear the doubts. If not, I will start the lecture. If you are having any doubts, the one who are in the live, once you text a hi Nana so that I can start a class. The one who are in the live, so that once if you say hi or anything, sir, if you say me to start the class, I will start the class, so that whatever the doubts, everything they are having, I was cleared, I think so. మీకు ఏమన్నా డౌట్స్ ఉన్నాయి అంటే ఇప్పుడే అడగండి, ఐ విల్ క్లారిఫై ఇట్. లేదు క్లాస్ స్టార్ట్ చేయండి అంటే ఐ విల్ స్టార్ట్ ద క్లాస్. Hi sir, how much did you score it? No. Nana, if any that type of the questions, how much did you score, how much marks you have got in the your graduation, నీకు ఎన్ని మార్క్స్ వచ్చినాయి ఎంఎస్సిలో, మీరు ఎక్కడ చదివినారు, ఆ పర్సనల్స్ అన్నీ ఒకరోజు పర్సనల్ లైవ్ పెట్టుకుందాం. ఆ లైవ్ పెట్టుకొని మనం ఆ మోటివేషన్ ఐ విల్ గివ్ యూ ద పర్సనల్ మోటివేషన్. బట్ ఇది లెక్చర్ కాబట్టి లెట్ మీ స్టార్ట్ అండ్ లెట్ మీ కంటిన్యూ ద లెక్చర్. సుహాస్ ఉన్నావా? ఓకే, ఎనీ పర్సనల్ క్వశ్చన్స్ అండ్ ఎవ్రీథింగ్ ఇఫ్ యూ ఆర్ హ్యావింగ్ దట్, వన్ డే ఐ విల్ మెన్షన్ ద లైవ్ ఫర్ దట్ వన్, motivation to start the organic chemistry or motivation to start the chemistry. There we will discuss, because the class is getting lag. The one who are waiting for the lecture, it is becoming lag. Okay, done. That all I will explain one day. ఒక రోజు లైవ్ పెడతా నేను, ఎట్లా ఏవి ఏమేమి బ్యాలెన్స్ చేయాలి, ఏవి ఎట్లా బ్యాలెన్స్ చేయాలి అవన్నీ ఒకసారి లైవ్ పెడతా. ఇప్పుడు జస్ట్ క్లాస్ వినండి, లిజన్ టు ద క్లాస్. ఏమన్నా మీకు ఏమన్నా పర్సనల్ క్వశ్చన్స్ ఏమన్నా కావాలి అని అంటే పర్సనల్గా ఒకరోజు లైవ్ పెడతా, అక్కడ మనం క్లారిఫై చేసుకుందాం ఆ లైవ్లో. ఓకేనా? జస్ట్ ఇప్పుడు మనం క్లాస్ స్టార్ట్ చేద్దాం. ఆ క్లాస్లో కావాల్సిన ఏమన్నా డౌట్స్ ఉంటే, ఆ లెక్చర్కి సంబంధించిన ఏమైనా డౌట్స్ ఉంటే అడగండి. డన్. నౌ first, preparations of the alkynes by the industrial method. Now in the industrial method, when they have taken the 2 moles of the methane gas at a high temperature, then when it is taken the high temperature, directly it is giving the acetylene gas. Okay, that only acetylene gas only we will call it as a ethane gas. Clear? Then it is releasing the 3 moles of which one? Hydrogen gas. Clear? This ethylene gas is a thermodynamically unstable. It will readily convert into the element. Clear? What? Here this ethylene gas which has been generated here, C2H2 gas, it is thermodynamically, it is unstable. Then what it will happen? It will be converted into the 2 carbon solid and it will release the H2 gas. Then acetylene is stored in the which one? Commercial cylinders that contain the pure saturated with the which one? That is stored with the pure saturated with the acetone. Clear? Next one, next preparation from the second type of the preparation that we are having the, if you take the 2 moles of the carbon and when we pass in the presence of H2, dielectric arc or electric arc at a high temperature, what it will give? It will give the acetylene gas. Then next, from the next preparation method, with the coke of the carbon and with the lime. Now coke of the carbon from the lime, from lime This is CaO and coke, carbon coke. Done. How it will be reacted? Now you see, calcium oxide, when it is reacting with the 3 moles of the carbon, when it is heated in the furnace, heated in one furnace at a high temperature, then what it will do? It will give the calcium carbide, CaCl2, and it produces the CO gas. But this calcium carbide which it has provided, or which we have got, now this calcium carbide will be in this manner. Now this calcium carbide, again it will be react with the 2 moles of the H2O, and it will produce the which one? Acetylene, or alkyne it will be produced, plus calcium hydroxide it will be produced as a byproduct. In the same way it will react with the magnesium carbide also. Magnesium carbide will be Mg2C3. Now Mg2C3 it will be Mg plus 2 and C3, and it is having the charge of -4. Then again this Mg2C3, again when it is reacting with the 4 moles of H2, then what it will give? It will give CH3, C triple bond CH, plus 2 moles of magnesium hydroxide. These are the some preparation methods of what? Triple bond. Triple bond is nothing but alkyne. Then next, another preparation method, double dehydrogenation. Double dehydrohalogenation reactions also will provide the which one? Alkyne. See, this reaction will play a very crucial role in the conversion. Many of the students, they will get the mistake, or they will make the mistake here itself. In the double, when this alkyne question they have given, they will make the mistake. See, double dehydrohalogenation reaction, how the double dehydrohalogenation reaction will be happen? Now we'll see. Now first, alcoholic KOH is the which one? Base. Now this base will readily abstract the H plus here. Then what happens? Now this bond it will be glyced and the Br will be eliminated. Then first what it will generated? Now alkene will be generated like this. Now when the alkene has been generated, then after that again another mole of which one? Sodium amide. Another mole of sodium amide. Sodium amide in the presence of liquid ammonia. Sodium amide in the presence of liquid ammonia. This sodium amide is also a one base. Then readily abstract this proton or this hydrogen. Now what it will happen? Now this sigma bond will be delocalized and the Br will be eliminated. Due to that, what we are getting? We are getting the triple bond. That is known as a what? Double dehydrohalogenation. First dehydrohalogenation we have did with the alkalic OH. Then after that, sodium amide in the presence of liquid ammonia. Many of the students, they are getting mistake, and they are doing the mistake with the sodium amide. Clear? You can see here, whenever the alkene if they have given in this manner, whenever the alkene if they have given Br and the H if they have given, done. Now this is sodium amide. This is sodium amide in the presence of liquid ammonia if they have given. This is not the Birch reduction. Many of the students, they are getting mistake and they are thinking that this is a Birch reduction. My dear friend, this is not the Birch reduction. You have to be very careful with this one. Clear? This is the one base. This is not the which one? Birch reduction. This is the base. Now it will readily abstract the hydrogen and it will form the triple bond. In this manner. Clear? This is very important reaction. Then after that, dehydrohalogenation of the tri or tetrahalides. With the tri and tetrahalides also we can prepare the alkanes. Now with the tri and the tetrahalides, how we can prepare the halides means, now I was taking the one chloroform. This is a chloroform. Now chloroform in the presence of Ag metal, and when we are eating, This is the Cl and this is the A. Done. Now in this it will be eliminated as the which one? As the 6 moles of the AgCl it will be eliminated. Then what it will give? It will give the acetylene gas. It will give the acetylene gas and it will convert into the AgCl. AgCl. Clear? In this manner also we can prepare. Done. Next. Next reaction we are going to see. Now coal base electrolysis also. From the coal base electrolysis also we can prepare the which one? With the coal base electrolysis also we can prepare the with the coal base electrolysis also we can prepare the which one? Alkyne. Clear? Now if suppose if they have taken now COOK double bond, now COOK and H. Done. This upon electrolysis, either you can take the trans or cis, anything you can take. This upon the electrolysis, directly it will give you the which one? One acetylene gas plus and CO2 gas at a anode. And H2 gas will be produced at cathode. H2 gas will be produced at cathode and it will produce the 2 moles of alcohol. 2 moles of the alcohol it will be produced. Done. Now next the physical properties of the alkynes will see. Physical properties of the alkyne. Physical properties of alkynes. In the physical properties of the alkynes, what are the physical properties of the alkynes? First one, in the physical properties of the alkynes, in the pure state acetylene is a colorless gas. Clear? In the pure state this acetylene in pure state is colorless gas. First one. Done. Second one, in the acetylene now this acetylene carbon hybridization are sp2, this is sp. Done. Next, alkynes are more electronegative than the alkenes and the alkynes. Clear? Now the second one, alkynes are more electronegative than alkenes and alkanes. Due to the more percentage S character. Clear? Now here, my dear friends, anyone who are in the live, once you say me hi in the comment section or in the chat box. If anyone are in the live, the students who are in the live, once you text or say me hi in the live or in the chat box. ఎవరన్నా లైవ్ లో ఉంటే హాయ్ అని పెట్టండి అమ్మా చాట్ బాక్స్ లో. So that I can start the conversion questions also from here, because the reactions will be very very important. Okay, triple bond reactions are very very important. Okay, done. Now we'll see the chemical properties of the alkyne. Chemical properties of alkyne. Chemical properties of the alkynes In the chemical properties of the alkynes, first reaction we are going to see RC triple bond R in the presence of 2 moles of H2, palladium, 2 moles of H2 and the palladium, what it will get? R CH2 and CH2 R, because this is catalytic hydrogenation reaction it will do. Now whenever the triple bond upon the catalytic hydrogenation reaction, directly it will convert into the alkane. Directly it will convert into the alkane. If suppose triple bond if they have given, if suppose the triple bond if they have given in the presence of H2 or palladium and the platinum, H2 in the presence of palladium and the platinum, done, or if you have given palladium in the presence of barium sulfate and the poisonous sulfur if they have given, and if suppose if they have given the metal in the presence of liquid ammonia, if suppose if they have given, then what it will do, this alkane will stop the reaction at which state? Alkene stage only, and alkene stage, that it will give you the cis alkene, that cis alkene is cis butadiene, and this one will give you the trans butadiene, and this one will give you the trans alkene. Done. Now next, addition of halogens to the second type of the reaction we are having, that is addition of halogens to the which one? To the alkanes. Now how the alkanes will add to the halogens, now we'll see. Now this is a which one? Alkyne, or else better we'll take the 1 degree, sir, 1 triple bond containing compound. Done. This is a which one? Ethyne upon 2 moles of Br2 in the presence of CCl4. In the CCl4, what it will happen? First this alkyne will be attacked to the Br end. Now this is a Br, right? Clear? Now this alkyne it will be attacked to the Br at its here at this end. Then what happened? This bond pair of electron will be shifted toward this Br. Then here this carbon, for this carbon the Br will be attacked, and the another carbon it will get the positive charge. Again this negative charge of the carbon will go and attack in this manner. One here it is a Br, and one it is a Br, and here it is a H. Now here it is a H. Clear? Again we are having the another mole of the Br, right? Because total 4 Brs we are having. Clear? Now only the 2 has added. Then the another Br, same reaction it will do. Then what it will happen? What it will get? Here the Br, here the Br, here the H. Now here it is a Br, now here it is a Br, and here it is a H. In this manner it will be attacked. Clear? Done. This is about the addition of Br2 in the presence of CCl4. Next, if suppose if they have given, done, in the presence of 2Br2 and CCl4, then what is the product we will get? All the Brs will be added to the which one? That alkene or alkyne carbon. That alkyne carbons where the double bonds are there it will be converted into the single bond by adding of Br to the carbons. Then next, very most important reaction that we are going to study, that is the addition of H2O to the triple bond. Many of the students, they will make the mistake here, and repeatedly they are asking the question from this concept, addition of H2O. This reaction we call it as a Kirchhoff reaction. Kirchhoff's reaction. Addition of H2O, we call it as a Kirchhoff's reaction. Now what are the reagent that we are going to take in the Kirchhoff's reaction means? Clear? Now addition of H2O in the presence of 60% H2SO4 and 1% HgSO4. Clear? Now here the oxidation state of the Hg is +2. Now as a catalyst at 333 Kelvin, That the reason the rearrangement here the tautomerization will be happened. Many of the students they will get them, they will do the mistake here itself. Whenever the triple bond they have given, now we'll take the mechanism here. Mechanism, when the triple bond they have given, in the triple bond when the Hg plus 2 if they have given, then what it will happen, this Hg plus 2 this pi bond will be given its electron density to the Hg, then here the carbon, here the hydrogen, here the double bond, now here it is a Hg, now here it is a hydrogen. Now it is this electrophile, it is having the lone pair, done that. What it will do, that one pair of electron, what it will do, that it will be given to this electron deficient carbon. When it is given this electron deficient carbon, then what it will happen, here the cyclic ring it will form. In the cyclic ring when it has formed, then after the formation of this cyclic ring, then we are having the OH minus. That OH minus will go and attack to the any of the carbon, because this is symmetry, and this bond will be shifted towards the Hg. Done. Then after when this bond has been shifted towards the Hg, now here it is a H and here it is a double bond, now here it is a O and here it is a H and here it is a H. Now you can see this is the enol, this is the enol. Now this one we call it as a enol. Then the enol is a unstable. Now enol is a unstable. For when the enol is a unstable, what it has happened? Now 1,3 proton transfer will be happened. How the 1,3 proton transfer will be happened? Now this sigma bond, when the Hg has been eliminated, when it has taken this bond pair of electron and the Hg when it has eliminated, what it will get? 1 minute. No, right. No. What is the doubt you are having? Sir, can you share your GOC and hydrocarbon notes in the PDF form? I will prepare only this for Monday's test. Already I sent it, right? In the group I was sent it. Already I was sent it in the group. నేను గ్రూప్లో సెండ్ చేసిన, ఒకసారి క్రాస్ చెక్ చేసుకో. నీ పేరేంది నాన్న? వాట్ ఈస్ యువర్ నేమ్? హూ ఇస్ దిస్ స్ట్రిక్? నేను ఎక్కడ షేర్ చేయాలి నీకు? హౌ కెన్ ఐ షేర్ యూ? Abhinaya? Is it Abhinay? I will share to you that Ayush, already I sent you the mail ID. Now the mail ID already I was provided, right? That to the mail ID you can text me. I will send the GOC and the hydrocarbon notes. మరి నేను కూడా టైం వచ్చినప్పుడే పంపిస్తా నానా. హిస్టరీ ఎక్స్ నేను కూడా టైం వచ్చినప్పుడే పంపిస్తా, సరేనా? టైం వచ్చే వరకు వెయిట్ చేయి. ఆ టైం వచ్చే వరకు వెయిట్ చేయి. ఆ పీడిఎఫ్ని జిఓసి హైడ్రోకార్బన్ నీ చేతికి వచ్చే వరకు వెయిట్ చేయి. నౌ హియర్ then when this OH minus, when it is attacked to this carbon, now it is shifted toward this one. Then here the enol form is unstable. Then when this enol form is unstable, what it will happen? Here this hydrogen, when it has eliminated, now this sigma bond will be delocalized here, and this pi bond will be, or this pi bond will be shifted towards the carbon. Telugu, Ayush, I was speaking Telugu. Okay, the one who are in the live, already I was given my mail ID. Once you text me to that mail ID, I will give you the complete notes of the GOC and the complete notes of the hydrocarbon. Okay, I will send. How can I send to you? Because this is an online platform, I cannot send. Better I will keep the, once you text me to my personal mail ID which I was provided in the here also, once again I will provide, and in the chat box also, in the description box also I was given the mail ID of the mine channel 1 where to inquire, or else this is my personal mail ID. You can text me over there. I can share the PDF of the complete GOC notes for you. Complete GOC PDFs I will send, and with the including short notes also. If you are the dropper, you can prepare that short notes also. This is my mail ID. You can text me over there so that I can send the whatever the chemistry notes you need. I will send it over there. Now next, when this what pi bond has been shifted here, now the Hg will be eliminated. Then whatever the H place it has been eliminated here, that it will be converted into the aldehyde in this manner. That it will be converted into the which one? Aldehyde. Here you can see this is a H, and here it is a H. Then here, sorry, wait. When this hydrogen, not here, this is the enol. This is the enol is unstable. Now this hydrogen, it will be this Hg, it will be eliminated. When this Hg it has been eliminated, now whatever the H place it is there, now that it will go and attack to this carbon. Then when this attacked this H, sorry, here it will take. Now when this Hg has been eliminated, now whatever the hydrogen it is there, that it is go and attack to this carbon. Now it will get the double bond, and here it will get the OH, and here it will get the H. Now this enol, this whatever the enol it has formed, that is it is unstable. Now this enol it is unstable. Now this bond will be rotated here, and this carbon, this sigma bond will, this pi bond will be shifted toward this carbon, and this hydrogen it will go and attack here. Now what it will generated? It will generated the aldehyde here. What it will generate? It will generate the aldehyde here. Now in this manner, whatever the alkyne we have taken, alkyne in the presence of Hg, and the constant or the 60% of the H2SO4 if we have taken, now what it will give? It will give you the aldehyde. Now if suppose prop 1-ine if they have given, if suppose the prop 1-ine if they have given, prop 1-ine in the presence of dilute H2SO4 and HgSO4 and H2O if they have given, directly what it will give? It will give you the product ketone. It will give you the product, what it will give? It will give the ketone. Then here also same, it will form CH3, C double bond, here the H, and here it will be the Hg. Then after the Hg, here the CH3, here the C. Now here the OH will be added, here the double bond, here the Hg, and here it is a H. Then after the Hg eliminated, now whatever the hydrogen it is there, it will be added over there. Now the CH, here the OH, now here the double bond, now here the H, and here the H. Now again this is the enol, it is unstable. Now this now here the hydrogen, this bond and the hydrogen what we are having, now this will be delocalized, and this hydrogen will go and attack here. Now what we will get? We will get the ketone here. We will get the ketone here. In this manner the product we will get. Done. Now next, addition of allo acids or acid halides. Now next one we are going to see the reaction of the which one? Halogen acids, which follow the Markownikoff rule and the anti-Markownikoff rule. Which one will produce the Markownikoff rule and which one will produce the anti-Markownikoff rule? Now we have to see. Now my dear friends, my voice is clear, right? The one who is in the live, once you say me, is my voice is clear? Can anyone, the one who is in live, can anyone say my voice is clear? Now we'll see the reaction with the Markownikoff rule and the anti-Markownikoff rule. Here the first reactions with halogen acids. Reaction with halogen acids. Okay, so done. Reaction with halogen acid. No, class lo. Okay, fine. Done. Now I will start the questions. Then I thought that no one is in the class, so I was teaching myself. Once if you are in the live, the one who are in the live, once you text me, so that I get to know that you are there, so that I can ask you the questions, so that it will be clear for you also. I thought that no one is in the class. Okay, fine. No, okay. Now we'll start the reactions. We'll do the questions. Okay. Suhas, we'll do the questions. Okay. Fast ga ivi chemical properties of the alkanes complete chesesta. I will finish this chemical properties of the alkanes and we'll do the questions. Then if suppose if they have given the what but1 upon HBr, sorry, but1, this is a but19, sorry, but19 upon HBr and HBr in the presence of I can say very most congratulations to that institution as well as the student who has scored the 686. See, my dear friends, the one who are preparing for the NEET last time we have got the many allegations on the NEET that they have released, they have just they have leaked the paper, and last time almost 10 to 17 students they have scored the 720 out of 720 in the NEET, but this time none of the students have crossed the 700 above, and very few, less than 25 to 50 students have crossed the 650. So the NEET is also not an easy task, and many of the students, and my suggestion for you, stricting of the NCERT is a high priority for the which one, the one who are preparing for the NEET. For JEE is also NCERT is enough, but somewhat high level of the NCERT we have required, somewhat high level of the NCERT for the more calculation and the more number of the questions to required for it. Okay, done. Now now the one who are in the online, can you say me the IUPAC names of the A and B? Sorry, this is not the H2O2, better you take it as a R2O2. Can anyone say the IUPAC names of the A and B? The students who are in the online, can anyone say the IUPAC names of A and B? Can anyone say the IUPAC names of the A and B? Can anyone say the IUPAC names of A and B? If you know, say me. If not, give me the question mark. I will explain. If you know the answer, say me. See, this is the HBr. HBr is a Markownikoff rule, it will follow. And HBr in the presence of peroxide, it will follow the anti-Markownikoff rule. Done. HBr in the peroxide, here we are having the alkyne. Alkyne means completely the double bond it should be eliminated, because the plenty of the H2O it will be what HBr we are having. Now this HBr, what it will happen? Now the 2 moles of the Br will be added, because carbocation will be generated at the which one? Carbocation will be generated at the here if the carbocation, if it is generated here, it is 1 degree carbocation, it is unstable. So the internal carbocation will be generated and the 2 moles of the Br will be added, because HBr will be the plenty. Then if the anti-Markownikoff rule, if they have given anti-Markownikoff rule, now the negative part of attacking reagent will go and attack to the carbon or alkyne or alkene carbon contain less number of hydrogens or more number of hydrogens, where it will contain the more number of hydrogens. Done? Clear? Is it clear? Should I give the questions based on this? Should I give the questions based on this? Should I give the questions based on this? No. Better I will give you the one question so that it will be clear for you. Wait, we'll see the question based on. Now say me the product. Now normal HBr has given. Normal HBr. 2 moles of HBr has given. If you know the answer, you just say. If not, text me over there. Should I say the answer or will you try? Should I say the answer? If you know the answer, you say. If not, give me the question mark. Give me the question mark so that I can say the answer. డైబ్రోమోఈథీనా? నువ్వు బుక్లో చూసి చెప్తున్నావు, అది రాంగ్. డైబ్రోమోఈథీన్ అది రాంగ్. అది ప్రోడక్ట్ షీ రోట్ రాంగ్ ఓవర్ దేర్. నువ్వు బుక్లో చూసి చెప్తున్నావు సుహాస్, అది రాంగ్. అది ఆ ప్రోడక్ట్ రాంగ్. నువ్వు అక్కడ కార్బన్కి వ్యాలెన్సీ సాటిస్ఫై చేయి. కార్బన్కి వ్యాలెన్సీ సాటిస్ఫై చేస్తలేవు. Now you see, if I was shifted this pi bond to this carbon, now here it is having the H plus and here it is having the Br minus kada. Now this carbon will get the which one? Positive charge, and this carbon will get the negative charge. This negative charged carbon will be attacked by the which one? H plus, and Br minus will go and attack here. First we will get in this manner. Done. Then again the another mole of the which one? Here we will get the Br. again the pi bond will be shifted to the carbon. Here this one will be shifted here, and this H plus will go and attack here, and the Br minus which it is there, that it will go and attack here. Sir, can I understand the concept, but I am having the problem in solving questions. Now that what I am explaining, that what I was explaining from the last class. Many of the students, they are making the mistake where they are making the mistake. They are just mug-upping. Try to maintain the short notes. Maintaining of the short notes is the high priority. Maintaining of the short notes is the high priority for the which one? For organic chemistry. Now, next one. Next, the next type of the reaction. Yes, good. 1,1 dibromoethane. Good, my dear Dr. Ankush BM. Ankush, in your MBBS also this IUPAC it is there. ಏನಪ್ಪ ನಿಮ್ಮ MBBS ಅಲ್ಲೇನೋ IUPAC ಇದೆಯಾ? ಇನ್ನು IUPAC ಓದ್ತಾ ಇದೆಯಾ ಏನೋ? Here next we are going to see the addition of HOX. Now the next type of the reaction. Sorry. Okay, fine. Now the next we are going to see the addition of HOX where the X is not equal to, no, it is not Tamil, it is Kannada. I know only Telugu and English and Hindi and Kannada, not that much fluency, but I know. The students, this Ankush BM and the students from the Karnataka, when I was working in Mysore, they have helped me in teaching they have helped me in their language to teach me very fast. In that the I role is from Ankush BM in teaching Kannada to me, who is in MBBS second year. Sudarshan K, you are from Tamil Nadu. Sudarshan K, are you from Tamil Nadu? Now, next here, now Cl, Br and the I. Here where the X is Cl, Br and the I. Now if you take the alkyne, okay, good. But I will learn. I was trying to learn the Tamil, but I am not getting any time to learn because I was worked in the Mysore, so I get to know that Kannada. And the Telugu is my mother tongue, and the rest of the languages are English and the Hindi. Those are the basic languages. Right. Now, Sudarshan, you are in which stream? JEE, NEET, JEE or NEET or repeater? So, ಏನಪ್ಪ ಅಂಕುಶ್ ಇದೆಯಾ ಲೈವ್ ಅಲ್ಲಿ? No. Now the HOCl, JEE and sir, JEE and NEET repeater, sir. Okay. Oh, now actually the Karnataka students and the Tamil Nadu students. ಓ ಸರ್, ಓಕೆ ಓಕೆ. ಏನಪ್ಪ ಈಗ ನೀಟ್ ರಿಸಲ್ಟ್ ಬಂದು ಅದಕ್ಕೆ ಕಾಲ್ ಮಾಡಿದೆಯಾ ಏನೋ? ಸರಿ ಸರಿ ಸರಿ. ಈಗ ನೋಡಿ, ಈಗ ನಾನು ಕ್ವಶನ್ಸ್ ಕೊಡ್ತೀನಿ, ಸಾಲ್ವ್ ಮಾಡಿ. ಓಕೆ, ಈಗ ನಾನು ಸರಿ, ಈಗ ಈ ಆನ್ಸರ್ಗೆ, ಈ ಕ್ವಶನ್ಗೆ ಆನ್ಸರ್ ಹೇಳಿ ನೀನು. ನಾವು see, now the alkyne upon HOCl at one equivalent, then first of all what it will form? It will form the one three-membered cyclic. This it will form the cyclic intermediate it will form, because the chlorine it is having the lone pair of electrons, right? This electrophile, if it is having the lone pair of electrons. Okay, Nana, Sudarshan, okay, fine. For your case, I can help you in your chemistry. For your case, I can help you in your chemistry. Okay. Now when it is forming this cyclic transition, then we are having the base OH minus. This base OH minus will go and attack to this carbon. Now this carbon, this sigma bond pair of electron will be shifted towards the chlorine. Now R, this is the OH, and it is a C double bond, and here it is a H, and it is a Cl. Then here this is the enol form. Enol form is the unstable. This is the enol form, unstable. Now when this enol form is unstable, again it will due to the tautomerization. Due to the tautomerization, it will be converted into the now carbonyl group. Clear? In this manner it will be converted. Done? Now next type of the reaction is very important. Now halogenations of alkane. Halogenations of, okay, don't be nervous, Sudarshan. Now you got it as a 243 like that. Try to, you have taken the repeater, right? Try to strengthen and try to not to do the mistakes what you have did in your NEET. Okay, try to rectify those mistakes this time. Now halogenation of alkynes. Now in the alkynes, halogenation reactions are very important. Now this is a one but19 in the presence of NBS, CCl4 plus H nu, and Cl2 plus CCl4 and H nu. May I know what are the products we will get? A and B. What are the products A and B we will get? What are the products we will get A and B? If you know, try to give me the IUPAC names of the A and B. If you know, try to give me the IUPAC names of A and B. If you know, try to give the IUPAC names of A and B. If you know, try to give the IUPAC names of A and B. Hello Abhinay, hello sir. Allylic positions. Yes, 3 bromo but 19. Good. Because NBS, what it will do? It will attack the, it will replace the hydrogen which is at the allylic position. Whatever the hydrogen it is present at the allylic position, it will be replaced. Then due to the intermediate is free radical. Reaction, it will follow the intermediate is free radical, but product, this NBS allylic position hydrogen, it will be replaced and the Br will be added. So 3 bromo but 19. Good. No ine idu allylic position NBS upon alkene, ఇది ట్రిపుల్ బాండే కదా. This is triple bond kada. ఇది అలైలిక్ కార్బనే కదా, అలైలిక్ కార్బన్లో ఉన్న హైడ్రోజన్ రీప్లేస్ చేసి బ్రోమిన్ యాడ్ చేస్తుంది. ప్రోడక్ట్ బి సేమే, ప్రోడక్ట్ బి కూడా సేమే. ఇక్కడ సి వస్తుంది, ఇక్కడ కూడా హైడ్రోజన్స్ ఉన్నాయి కదా, ఇక్కడ కదా హైడ్రోజన్, ఇక్కడ కదా హైడ్రోజన్, హైడ్రోజన్ ఇక్కడ సిఎల్ వస్తుంది. సో హియర్ ద సిఎల్ విల్ కమ్. దట్స్ ఇట్. Here the Cl it has came, right? Next. Now the next type of the reaction we are going to see. Next type of the reaction. Okay, done. Next type of the reaction we are going to see. Now alkynes with neutral alkaline KMnO4, neutral and the alkaline KMnO4, 2-chlorobutane. Okay, not 2-chloro, 3 it will come, 3. This is 3 position, 1 2 3, 3-chlorobutane. Now alkynes with the neutral and the alkaline KMnO4, that we call it as a Bayer's reagent, right? Now this is a Bayer's reagent. Now alkaline KMnO4. Now alkaline KMnO4 upon but2-ine, what it will get? Alkaline KMnO4 upon but2-ine, what you will get? Can anyone? Alkaline KMnO4 upon but2-ine. What is the product IUPAC name? Alkaline KMnO4 but2-ine. What is the product we will get? What is the product we will get? OH will be a diol. Diol will form, sir. Butane 2,3 dione. Good. Butane 2,3 dione. First alkaline KMnO4, what it will do with the alkene? It will form the vicinal diol. Vicinal diol will form, right? First vicinal diol will form. Here this carbon here the OH, and here this carbon it is a OH, and here it is a OH. Again we are having the again double bond, right? Again this double bond, again it will be replaced with the vicinal diol OH and the OH. Now we know with the one carbon bearing the diols are unstable. One carbons bearing the diols are unstable. When the one carbon bearing the diols are unstable, what it will happen? Now H2 of the water molecule will be eliminated. Water molecule it will be eliminated. Then what it will give? Butane 2,3 dione. Butane 2,3 dione is a product. Clear? Clear? Because alkaline KMnO4 will do what it will do? Alkaline KMnO4 it will do the vicinal diol, right? But vicinal diol for the one carbon bearing the 2 hydroxy groups are unstable. That's the reason elimination of the water molecule takes place. Now here one question I will give you. One triple bond and one double bond if they have given. Oxidizing agent, yes, good. Now one triple bond and the one double bond if they have given, and aqueous KMnO4 they have given. Now what is the product IUPAC name? 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 What is the difference, sir? aqueous. Both are same only. Aqueous అన్న ఆల్కలైన్ అన్న సేమే, ఇట్లనే కన్ఫ్యూజ్ చేస్తాడు ఎగ్జామ్లో. aqueous అన్న ఆల్కలైన్ అన్న సేమే. చెప్పండి. వాట్ ఈస్ ద ప్రోడక్ట్ విల్ గెట్? సుహాస్కి తెలియదు అంటున్నాడు. పోనీ నిన్న నేను చెప్పిన కదా, ఇక్కడ KMnO4 is a strong oxidizing agent. Wherever the double bonds are there, it will form the vicinal diol. See, first when it is formed the vicinal diols here the OH and here it is a OH. The double bond will be converted into the vicinal diol, but the triple bond will be converted into the dione. Triple bond will be converted into the dione. Now you try to say me the answer. Now try to say me the IUPAC name, because here the on one carbon 2 hydroxy groups are unstable. Now you say me the answer. Now try to say me the answer, sir. Try to say me the IUPAC name for this one. Try to say me the IUPAC name for this one. What is the IUPAC name for this one? IUPAC name nana, among the alcohol and the ketone, which is high priority? Among the alcohol and the ketone, which is high priority? Among the alcohol and the ketone, which is high priority? Ketone. Good. Then 1,2 diol kaadu. Then if the no. Here if the alcohol ketone, if the alcohol is the acting as the functional group, then it will convert into the dihydroxy. Yes, correct. Then name of that one will be the name of that compound will become what? It will become what is the IUPAC name of that compound? 3,4 dihydroxy 3,4 కానీ నేను అందుకే ఐయుపిఎస్సిని మంచిగా చూసుకోండి అన్న. రాంగ్. మళ్ళా కాంపౌండ్ని మంచిగా చూడండి, డయోన్ కాదు, కాంపౌండ్ని మంచిగా చూడండి. See the compound and there we are having the 3 functional groups. 3,4 dioxo butane 1,2 diol. అది రాంగ్. మనకి ఆ ఇచ్చిన కాంపౌండ్ లో 3 ఫంక్షనల్ గ్రూప్స్ ఉన్నాయి. నానా దిస్ ఈస్ ఆల్డిహైడ్. ఇది ఆల్డిహైడ్ ఫంక్షనల్ గ్రూప్, కీటోన్ ఫంక్షనల్ గ్రూప్ కాదు. మీరు ఎందుకు కన్ఫ్యూజ్ అవుతున్నారు? దిస్ ఈస్ ఆల్డిహైడ్ ఫంక్షనల్ గ్రూప్. This is aldehyde functional group, not the ketone. So the compound name, now you say me, this is ketone functional group, this is a alcohol functional group, and this is a ketone. Among the 3 functional group, aldehyde functional group is more major. అందుకే నేను మంచిగా చూడండి కాంపౌండ్ ని అని చెప్పిన. డయాక్సో, డయోల్, dihydroxy, you are seeing that one only, but you are not seeing the compound properly. I said you to see the compound properly. The 2 degree prefix for both are same. How come the 2 degree prefix will be same? Nana, here the aldehyde functional group, right? Aldehyde and the ketone, which is high priority. Aldehyde and the ketone, which is high priority in the functional group. Aldehyde is a high priority, right? Aldehyde is a high priority. Prefix, no, that ketone you will take it as a oxo. Now for the aldehyde we'll take it as a formyl. Then 2-oxo, rest. Butanol, yes, correct. Here the IUPAC name will be 1, 2, 3, 4. Then among the hydroxy H and the oxo, which one will come? H will come, right? So 3, 4 dihydroxy 2-oxo butane 1 all. Butane 1 all. This is the IUPAC name of this compound. So you have to be very careful with this type of the reactions. Now, next very important we are going to study, that is ozonolysis of alkyne. Ozonolysis of the alkyne. Ozonolysis of the alkynes we are going to study. Now we know oxidative ozonolysis and the reductive ozonolysis. If the zinc is present, that it will stop the reaction at the aldehyde stage. If the zinc is not present, then the reaction will move to the carboxylic acid state, right? Then here first, if suppose any alkyne they have given. Now alkyne in the presence of O3 plus Zn. Clear? Now Zn, it will stop the reaction at the which stage? Aldehyde stage. Why? Whatever the peroxide it has formed, that it will be destroyed by the Zn. Now we will see the reaction. First what it will form? It will form the one ozonide, which is a unstable. One unstable ozonide it will form. Now in this manner the one unstable ozonide will be formed. Then after the unstable ozonide, when it has formed, then it will be converted into the glyoxal. Now it will be converted into the glyoxal in this manner. These are the all aldehyde functional group. Clear? Then plus H2O2. This is a peroxide is a mild oxidizing agent, right? This is a mild oxidizing agent. Then after this mild oxidizing agent, if suppose the zinc is not provided, then what it will happen? This mild oxidizing agent, this will convert that into the which one? Here the C double bond O, oxalic acid, it will be converted. It will be converted into this oxalic acid. Now oxalic acid, again it will be converted into the 2CO2. Done. Then if suppose the zinc is provided, then the zinc is provided, then what it will happen? Then this glyoxal upon the zinc, what it will do? It will be converted into the alcohol. Now it will be converted into the ethylene diol. Clear? It will be converted into in this manner. Ethylene diol it will form. Clear? Done? Next. Next, here also we are going to see the hydroboration reaction with the triple bond. Now if suppose the hydroboration reaction with a triple bond. Hydroboration reaction with the triple bond we'll see. Now CH, triple bond, CH. Now what is the reagent that we are going to see? Diborane in the presence of tetrahydrofuran. Now here what it will form? In the presence of peroxide and the base, if you take directly, it will be converted this product into the which one? Aldehyde. Why it will convert it the aldehyde? Because in the middle it will form the enol. In the middle it will form the enol. In the enol it is unstable, so directly it will convert into the which one? Aldehyde. So you have to be very careful. Alkene upon diborane or which one? Hydroboration, it will convert it into the alcohol. But alkyne upon hydroboration, it will be converted into the aldehyde. Clear? We have to be very careful with this one. Okavela, if suppose unsymmetrical or symmetrical alkyne, if they have given bute-2-ine upon hydroboration, what it will do? It will convert into the ketone. Clear? Now This is a one very important point you have to remember. Aldehyde. Which one? One, if suppose hydroboration if they have given. Next. Now we'll see. Now the alkyne with the which one it will be reacted, with the which one it will react, and with the which one it will not react with the. Now we'll see. This is very important. With the alkyne, this alkyne reactions are very important. Now, if suppose if they have given this one, and if suppose if they have given this one, among the one and among the two, which is a more acidic? Which alkyne is a more acidic? Can anyone among the 1 and 2, which alkyne is a more acidic? More acidic alkyne. Which among the is more acidic alkyne? Which among the alkyne is a more acidic? Which among the alkyne? Terminal alkyne is a more acidic. Terminal alkyne is a more acidic. Good. Done. Now we'll see the some reactions of the terminal alkyne with the different metals. With the metals and the what it will do, now we'll see. If suppose now the terminal alkyne, when it is reacted with the which one? Sodium. Now it will generate the Na, acetylene, and it will generate the H2 gas. See, whatever how the reaction will be happened, you know, whether the given reaction, whether the reaction it will undergo or whether the reaction it will not undergo. How we get to know, you know, if we have taken this one, what is this one? This is the one, let's suppose this is a reactant. This reactant is less acidic, let's assume. Then in the product side, if the more acidic if it is giving, then the reaction will not be happen. If the reactant is a more acidic, and in the product side if the any less acidic if it is generating, then the reaction will be happen. These are the two key points you have to remember. Okay, when the reaction will be happen means less acidic if it is provide the more acidic, no reaction. More acidic in the product side if it is generating the less acidic, then the what it will be generated, what the reaction will be happen. Here the hydrogen it is generating, so the reaction will be happen with the sodium hydrate. Now if the sodium hydrate also, with the sodium hydrate also it will produce a H2 and the reaction will be happen. Clear? Now with the sodium amide, sodium amide also the reaction will be happen. Why? It will generate the ammonia. It will generate the ammonia here. Ammonia gas it will be generated. So reaction will very important with the Grignard reagent. With the Grignard reagent also it will be happen. Clear? Now the Grignard reagent it will produce the alkane because this hydrogen is a more acidic hydrogen. Done? It will form the Grignard reagent in this manner. O- and the MgX. Grignard reagent it will form, but it will not react with the sodium bicarbonate. This alkyne will not react with the sodium bicarbonate because here the product carbonic acid which is generating, that carbonic acid is more stronger than the alkyne, so it will reaction will not be happen. Then again it will not react with the base also. What? Sodium hydroxide, because here it is generating the H2O. H2O is also more acidic than the which a terminal alkyne. That's the reason here with the sodium bicarbonate and the NaOH, terminal alkyne will not be react. Terminal alkyne will not react. Clear? Now by this we have completed the alkynes and its reaction. Now should I start the electrophilic aromatic reactions? If you are having, నాకు చెప్పండి బేసిక్స్ నుంచి స్టార్ట్ చేయనా లేకపోతే మనకు రియాక్షన్స్ ఉన్నాయి కదా ఫ్రీడల్ క్రాఫ్ట్ ఆల్కైలేషన్ అసైలేషన్ బికాస్ మై డియర్ ఫ్రెండ్స్ ఐఎమ్ సేయింగ్ యూనా అరోమాటిక్ ఎలక్ట్రోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్ ఏదైతే మనం చదువుతున్నామో అది ఎంటైర్ ఆర్గానిక్ కెమిస్ట్రీ ఇట్ విల్ బి యూస్ఫుల్ ఫర్ అస్. In the entire organic chemistry, aromatic, electrophilic, substitution reactions, that every chapter we are going to study. In the alloalkene alloarenes, we are going to study the reactions with chlorobenzene. Clear? In the alcohols and the phenols and the ethers, we are going to study the aromatic electrophilic substitution reaction with the alcohol, with the phenol and with the anisole. Then when it comes to the aldehyde, in the carboxylic acid group, we are going to study with the benzaldehyde and a ketone. Then we are going to study with the benzoic acid. But when it comes to the amines, there we are going to study this aromatic electrophilic substitution reactions with the aniline. So aromatic electrophilic substitution reaction, whatever we are going to study, will play a very, very crucial role in each chapter of the organic chemistry. This application is same only. Same, that formation of the electrophile, second sigma complex, and the elimination of the H plus. Ring activating and the ring deactivating అవే కదా, అవే దట్ ఓన్లీ. కానీ Cl2 ఇచ్చినప్పుడు ఎట్లా రియాక్షన్స్ అవుతాయి, ఆల్డిహైడ్ ఇచ్చినప్పుడు ఎట్లా రియాక్షన్స్ అవుతాయి, బెంజోయిక్ యాసిడ్ ఇచ్చినప్పుడు ఎట్లా రియాక్షన్స్ అవుతాయి, అవే కదా మనకు తెలియాల్సింది. ఆ రియాక్షన్సే మరి రఫ్గా ఎక్స్ప్లెయిన్ చేయనా? ద వన్ హూ ఆర్ ఇన్ ద లైవ్, వన్స్ యూ కామెంట్ అనా, so that I can get to know the aromatic electrophilic substitution reaction is a very, very important. So if you want me to explain roughly, I will explain roughly. I mean roughly in the sense just with the very less questions, because actually I brought the n number of questions. I thought of doing those one so that it will be helpful for the hydrocarbons application. So if anyone are in the live, they can text me, I want to explain it from the basics, or I want to explain it roughly. If you ask me to explain it in roughly, I will explain it roughly. If you want me to explain it from the basic, I will explain it from the basics. Done? Roughly is okay, sir. Okay, Kanyan. Chal. Now we'll start the. Sir, in క్వశ్చన్స్ మీరు చేయడం కాదురా, దాన్ని ఇక్కడ నేను సాల్వ్ చేస్తే మీకు ఒక క్లారిటీ వస్తుంది. అట్లా అంటే నేను తక్కువ క్వశ్చన్స్ అయితే ఇచ్చిన, కానీ ఆ తక్కువ క్వశ్చన్స్లో ఎక్కువ కాన్సెప్ట్స్ ఉన్నాయి. అంటే హైడ్రోకార్బన్స్ ఆల్ ద కాన్సెప్ట్స్ క్వశ్చన్స్ ఉన్నాయి. అట్లా సరేలే, నేను గ్రూప్లో పెడతలే. ఐ విల్ సెండ్ ఇట్ ఇన్ ద గ్రూప్. ఎల్లయ్య నీలం, ఇట్ విల్ కవర్ ద బేసిక్స్ ఆల్సో. ఎల్లయ్య నేను గ్రూప్లో పెడతలేను మీకు. ఎల్లయ్య ఐ విల్ కవర్ ఇట్ ఇన్ ద ఫ్రమ్ ద బేసిక్స్. బేసిక్స్ నుంచే కవర్ చేస్తా. నౌ వినండిగా, అరోమాటిక్ electrophilic substitution reaction. Now you have, why we are going to study aromatic electrophilic substitution reaction means మనకు తెలుసు కదా, alkene, this is the alkene and this is the one alkyne, alkene and the alkyne both are showing the addition reaction. Which reaction is are showing? Addition reaction చూపిస్తున్నాయి. But when it comes to the benzene is not showing the, which one? Benzene is not showing the what? Addition reaction. But benzene is showing the, what it is showing? Substitution reaction. If the benzene, if it is show the addition reaction to this electrophile, then what it will happen? Here it will get the electrophile and here it will get the nucleophile. Then you know aromatic, benzene is an aromatic compound and it is a stable. When it is show the addition reaction, it is becoming the non-aromatic. Making the aromatic compound non-aromatic is unstable. That's the reason only benzene will not show the addition reaction. That's the reason only the benzene is showing the aromatic electrophilic substitution reaction. Benzene is showing the aromatic electrophilic substitution reaction. Now how the aromatic electrophilic substitution reaction the benzene will show? Now we'll see. Now it is showing the aromatic electrophilic substitution reaction. First one, now what are the key steps it will follow? In the first step it will follow the formation of electrophile. Formation of electrophile it will be generated. Then second, sigma complex will be formed. Sigma complex will be formed. Now third one will be the elimination of H plus. This is the mechanism it will be follow in the which one? Halogenation, nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. In the three steps mechanism is only this one only. Step 1 formation of electrophile. Step 2 sigma complex. Formation of sigma complex. Step 3 elimination of H plus. One electrophile added, one electrophile eliminated. In the same way, in the cricket we used to see the substitution, right? One electrophile is coming, one filler is coming, one filler it is going from the ground. That is called as the substitution, right? In the same way, anni reaction ki halogenation ide steps follow aitadi, nitration ki ide 3 steps follow aitadi, ఇంకా ఏంటిది సల్ఫోనేషన్ కి ఇదే 3 స్టెప్స్, ఫ్రీడెల్-క్రాఫ్ట్ ఆల్కైలేషన్, ఫ్రీడెల్-క్రాఫ్ట్ ఎసైలేషన్. సో నేను ఒక్కదాన్ని ఫస్ట్ రియాక్షన్ ది మెకానిజం ఎక్స్ప్లెయిన్ చేస్తా, అన్ని రియాక్షన్ కి డైరెక్ట్ ప్రోడక్ట్ రాసేస్తా. ఎందుకంటే మళ్ళీ అక్కడ కూడా సంథింగ్ సేమ్ గా అదే ఎక్స్ప్లెయిన్ చేయడం అంటే టైం వేస్ట్. కానీ బిఫోర్ గోయింగ్ టు దట్ we have to know some groups which are added on the benzene. Which one will increase the electron density at ortho and para directing group, or which are the meta directing groups? Now we have to see. Okay, now I will write the some groups here or some compounds I will write. Which category it will come you have to explain. మీకు తెలిస్తే మీరు ఎక్స్ప్లెయిన్ చేయండి, తెలియకపోతే I will ask. No. Okay. Now this is a 1, this is a 2, this is a 3, this is a 4, and this is a 5, and this is a 6. Okay. Now here we know 6 compounds we are having. In the 6 compounds will be, which one will be increase electron density on the benzene at ortho and para positions fastly among the 6? Which one will readily increase the electron density on the ortho and para very fastly? Ortho and the para very fastly. First. Then second moderate ring activating group. Now second category, first one will be the OH, second one will be the second category. My dear Praneeth, ఒకసారి కాంపౌండ్లని అన్ని క్లియర్గా చూడు. Second one is NO2. Second one is a NO2. అన్ని 6 కాంపౌండ్స్లలో ఫస్ట్ ఎలక్ట్రాన్ డెన్సిటీ ఎట్ ఆర్థో అండ్ పారా పొజిషన్ ఫీనాల్ ఇంక్రీజ్ చేస్తుంది. మరి ఫీనాల్ ఇంక్రీజ్ చేస్తే సెకండ్ ఇస్ ద సెకండ్ కేటగిరీ. ఫీనాల్ తర్వాత ఆర్థో అండ్ పారా డైరెక్టింగ్ గ్రూప్లో ఎలక్ట్రాన్ డెన్సిటీని ఏ కాంపౌండ్ ఇంక్రీజ్ చేస్తుంది? 1 6 3 1 greater than 6 greater than 3. Then after yes, good. This is the methoxy will comes under the which one? Moderate ring activating group. Okay, moderate ring activating group. Then after 3, after that then 5, ఓ 2 సార్లు NO2 రాసినా నేను. ఓ సారీ 2 times I was written 2. Okay, okay. This is Cl. Sorry, I was written NO2 2 times. Now you say me. Sorry, 1 greater than 6 greater than 3. Okay. 1 greater than 6 greater than 3 greater than 5 greater than 4. Actually, I did not see Nana. Here I thought of writing in the NO2, but I written Cl. I thought of writing then 1 greater than 4 greater than 5 greater than 2. Good. Yes, because these are the Chandrapranit, whatever you have said is also correct. అది కూడా కరెక్టే. యాక్చువల్గా నేను ఇక్కడ సిఎల్ ఉందేమో అనుకున్నా, కానీ అది NO2 అని రాసిన. ఓకే, చంద్రప్రణిత్, వాట్ ఎవర్ ద రియాక్షన్ యూ సెడ్ దట్ ఈస్ ఆల్సో కరెక్ట్, దట్ సీక్వెన్స్ ఆల్సో కరెక్ట్. ఇప్పుడు వినండి. డన్. నౌ వి గాట్ టు నో విచ్ వన్ విల్ ఇంక్రీజ్ ద ఎలక్ట్రాన్ డెన్సిటీ అట్ ద ఆర్థో అండ్ పారా డైరెక్షన్. విచ్ వన్ విల్ ఇంక్రీజ్ ద ఎలక్ట్రాన్ డెన్సిటీ? See now the groups, which one will increase the electron density at ortho and para, and which one will increase the electron density at meta? Now this nitrobenzene are groups para directing groups, sir, ortho and para directing groups. In that ortho para directing groups, first one will be the O minus, then NH2, then OH, clear, then here the NHR. Now these are the some groups we are having. Moderate, in the moderate will come OCH3, clear. Now next acetanilide, then phenyl acetate, done, clear. Now weak ring activating alkali, CH3 is the first, then after the CH2, because more the number of alpha hydrogens we require. Then weak ring deactivating groups lo Cl, or sorry, not Cl, Br and iodine. This will comes under the, this will also, even though it is a ring deactivating group, it will increase the electron density at ortho and para positions. You have to be very careful with this one. ఇవి ఆర్థో పారా డైరెక్టింగ్ గ్రూప్సే. నెక్స్ట్ మెటా డైరెక్టింగ్ గ్రూప్స్ ఏవి? కార్బనైల్ గ్రూప్, కార్బనైల్ containing compounds, carbonyl group or carbonyl functional group containing compounds, and in that very strong will be the NO2, NH+3 and CX3. These are the some compounds we are having. Done. Now clear. Now we'll see the reactions, that how the reactions will be happened here. Now before going to that one, before going to start the reactions, here I will explain which reactions, if they have given, which product is major, para majora, ఆర్థో మేజరా అని మనకి రిపీటెడ్లీ అడుగుతూ ఉంటాడు కదా. నేను ఒక్కొక్క స్పీసీస్ రాస్తా. ఎలక్ట్రోఫైల్, నార్మల్లీ ఏదన్నా ఒక ఎలక్ట్రోఫైల్ తీసుకుందాం. ఆ ఎలక్ట్రోఫైల్ తీసుకొని ఎక్కడ ఆర్థో పారా డైరెక్టింగ్ గ్రూప్, ఎక్కడ ఆర్థో మేజర్, ఎక్కడ పారా మేజరో మీరు చెప్పాలి. ఇప్పుడు ఇక్కడ నేను ఈ కాన్సెప్ట్ ఏదైతే మీకు ఎక్స్ప్లెయిన్ చేస్తున్నానో అది ఎంటైర్ ఆర్గానిక్ కెమిస్ట్రీ మొత్తం యూజ్ అవుతుంది. మీకు ఎక్కడ కూడా ఎలక్ట్రోఫిలిక్ అరోమాటిక్ సబ్స్టిట్యూషన్ రియాక్షన్ క్వశ్చన్స్ ఇస్తే ఇది మీకు క్లియర్ అయితే మీకు ఎక్కడ ప్రాబ్లం అవ్వదు. అరోమాటిక్ సబ్స్టిట్యూషన్ రియాక్షన్ క్వశ్చన్స్ ఇస్తే ఎక్కడ అది పారామేజరా, ఏది ఆర్థో మేజరా, ఒకవేళ డై సబ్స్టిట్యూయెంట్స్ ఇస్తే మరి ఎక్కడెక్కడ యాడ్ చేయాలి, డై సబ్స్టిట్యూయెంట్స్ ఇస్తే ఎక్కడెక్కడ యాడ్ చేయాలి, ఒకవేళ ట్రై సబ్స్టిట్యూయెంట్స్ ఇస్తే ఎక్కడెక్కడ యాడ్ చేయాలి, ఏ పొజిషన్స్లో, ఒకవేళ ఎలక్ట్రాన్ విత్డ్రాయింగ్ గ్రూపు, ఎలక్ట్రాన్ రిలీజింగ్ గ్రూప్ ఉంటే దేని రిఫరెన్స్గా ఎలక్ట్రోఫైల్ యాడ్ చేయాలి, అవి ఎక్స్ప్లెయిన్ చేస్తా. క్లియరా? దట్ ఇట్ విల్ బి వెరీ వెరీ ఇంపార్టెంట్, చాలా అంటే చాలా ఇంపార్టెంట్. నౌ ద వన్ హూ ఆర్ ఇన్ ద లైవ్, వన్స్ యూ టెక్స్ట్ మీ హాయ్, నాకు ఎవరెవరు ఉన్నారో ఒకసారి తెలియాలి లైవ్లో, సో దట్ నేను 1 by 1 స్టార్ట్ చేస్తా. ప్రణీత్ ఉన్నాడు, ఇంకా ప్రణీత్, ఇంకెవరు ఉన్నారు, ఇంకా ఎవరన్నా ఆన్లైన్లో ఉంటే టెక్స్ట్ మీ హాయ్. చంద్ర ప్రణీత్ ఉన్నాడు, సరే రైట్. వినండి, సుహాస్ ఉన్నాడు, వినండి. ఇప్పుడు నేను ఏమేమి కాంపౌండ్స్ రాస్తున్నానో అవి చాలా ఇంపార్టెంట్, మీకు ఎక్కడ కూడా ప్రాబ్లం రాదు ఏదైనా ఇస్తే. ఫస్ట్ డై సబ్స్టిట్యూటెడ్ నుంచి పోదాం నాన్న. డై సబ్స్టిట్యూటెడ్లో ఇప్పుడు ఒక OCH3 ఇచ్చిండు, ఒక CH3 ఇచ్చిండు, ఓకేనా. ఇప్పుడు డై సబ్స్టిట్యూటెడ్ ఉంది, ఇక్కడ ఎలక్ట్రోఫైల్ ఉంది. మరి ఇక్కడ ఎలక్ట్రోఫైల్ ఎక్కడ అటాక్ అవుతుంది? ఇది ఆర్థోపారా డైరెక్టింగ్ గ్రూప్, ఇది కూడా ఆర్థోపారా డైరెక్టింగ్ గ్రూపే. మరి ఇప్పుడు CH3కి రిఫరెన్స్గా ఆర్థోనేమో ఈ పొజిషను, పారానేమో ఈ పొజిషన్, ఏది CH3కి రిఫరెన్స్గా. మరి OCH3కి రిఫరెన్స్గా ఆర్థో పొజిషన్ ఏమో ఇది, పారా పొజిషన్ ఏమో ఇది. మరి ఇప్పుడు ఎలక్ట్రోఫైల్ ఎక్కడ పోయి అడ్రస్ అవుతుంది? CH3 ఎక్కడ పోదునా? నేను ఏమంటున్నా అంటే, ఇప్పుడు డై సబ్స్టిట్యూటెడ్ ఇచ్చిండు బెంజిన్కి, అండ్ ఇప్పుడు మనం ఎలక్ట్రోఫిలిక్ సబ్స్టిట్యూషన్ రియాక్షన్ చేస్తున్నాం. మరి ఇప్పుడు ఎలక్ట్రోఫైల్ పోయి దేనికి రిఫరెన్స్గా యాడ్ అవుతుంది? ఇది ఆర్థోపారా డైరెక్టింగ్ గ్రూపే, ఇది కూడా ఆర్థోపారా డైరెక్టింగ్ గ్రూపే. నేను అదేగా చెప్తున్నా, ఇట్లాంటి క్వశ్చన్సే మీకు కన్ఫ్యూజ్ చేస్తాయి. ఇప్పుడు ఈ రెండు ఆర్థోపారా డైరెక్టింగ్ గ్రూప్లే. మరి ఇప్పుడు ఎలక్ట్రోఫైల్ దేనికి రిఫరెన్స్గా పోయి యాడ్ అవుతుంది? ఇప్పుడు నేను గ్రీన్ కలర్ స్పాట్లో పోయి ఎలక్ట్రోఫైల్స్ యాడ్ అవుతాయా, లేకపోతే రెడ్ కలర్ OH3కి రిఫరెన్స్గానే ఎలక్ట్రోఫైల్స్ పోయి యాడ్ అవుతాయి. అంటే ఇక్కడ విచ్ వన్ ఇస్ అ స్ట్రాంగ్ ఆర్థోపారా డైరెక్టింగ్ గ్రూప్? OCH3 ఇస్ అ స్ట్రాంగ్ ఆర్థోపారా డైరెక్టింగ్ గ్రూప్, కాబట్టి దానికి రిఫరెన్స్లో ఉన్న ఆర్థోపారా డైరెక్టింగ్ గ్రూప్లోనే పోయి యాడ్ అవుతాయి. అంటే ఇప్పుడు ఎలక్ట్రోఫైల్ విల్ గో అండ్ యాడ్ టు ఇయర్ 1, ఎలక్ట్రోఫైల్ విల్ బి యాడెడ్ OCH3, then here the CH3, and here it will be added, here the 1 electrophile. ఓకేనా. డై సబ్స్టిట్యూటెడ్ ఇచ్చిండు అంటే we have to go with the reference of which one? With the reference of the OCH3. ఓకేనా. ఇప్పుడు నెక్స్ట్ కాంపౌండ్ ఇప్పుడు సేమ్ అదే OCH3 ఇచ్చినాడు, మెటా పొజిషన్లో Cl ఇచ్చినాడు, మెటా పొజిషన్లో Cl3 ఇచ్చినాడు. ఇప్పుడు ఎలక్ట్రోఫైల్ విల్ గో అండ్ అటాక్ ఎట్ విచ్ పొజిషన్ అండ్ విచ్ ఈస్ మేజర్? ఇప్పుడు ఎలక్ట్రోఫైల్ మనకి ఇక్కడ ఛాన్స్ ఉంది, ఇక్కడ ఛాన్స్ ఉంది, ఇక్కడ ఛాన్స్ ఉంది. ఇప్పుడు ఎలక్ట్రోఫైల్ 1 కార్బన్ దగ్గర అటాక్ అయితే మేజరా, 2 కార్బన్ దగ్గర అటాక్ అయితే మేజరా, 3 కార్బన్ అటాక్ అయితే మేజరా? ఎందుకంటే జస్ట్ నౌ వీ హ్యావ్ స్టడీడ్ దట్ OCH3 ఈజ్ ద స్ట్రాంగ్ ఆర్థోపారా డైరెక్టింగ్ గ్రూప్, దాని రిఫరెన్స్గానే మనం ఎలక్ట్రోఫైల్ యాడ్ చేస్తాం ఈవెన్ దో ఇట్ CH3 ఉన్నా. ఇప్పుడు 1 కార్బన్ దగ్గర ఎలక్ట్రోఫైల్ అటాచ్ అయితే మేజరా, 3 కార్బన్ దగ్గర ఎలక్ట్రోఫైల్ అటాచ్ అయితే మేజరా, 2 కార్బన్ దగ్గర ఎలక్ట్రోఫైల్ అటాచ్ అయితే మేజరా? చెప్పండి. 2 or 3? లేదు, ఒక్కటే మేజర్ ఉంటుంది, 2 and 3 ఉండదు అన్న. 2 or 3 కాదు, ఒక్కటే. ఇక్కడ 1లో అసలు అవనేవదు, 1లో స్టీరిక్ క్రౌడ్ కాబట్టి ఇక్కడ అయ్యే ఛాన్సే లేదు. అమాంగ్ ద 2 and 3 చెప్పు, అమాంగ్ ద 2 and 3 ఏది మోర్ స్టేబుల్ చెప్పు, 3. గుడ్. 3 బికాస్ ఇట్ ఈస్ అ లెస్ స్టీరిక్ క్రౌడ్. నాన్న అందరూ ఎవరెవరైతే లైవ్లో ఉన్నారో ప్రతి ఒక్కరు ఆన్సర్ చేయాలి, ఇది చాలా ఇంపార్టెంట్. ఇప్పుడు మనం నెక్స్ట్ చాప్టర్ వీఆర్ గోయింగ్ టు స్టడీ ద ఆల్డిహైడ్స్ కీటోన్ కార్బాక్సిలిక్ యాసిడ్. అక్కడ ఇది వెరీ క్రూషియల్ రోల్ ప్లే చేస్తుంది, ఈ అప్లికేషన్ వెరీ క్రూషియల్ రోల్ ప్లే చేస్తుంది. అర్థం కాకపోతే అడగండి, నేను చెప్తా. ఓకే. నౌ హియర్ ద వెరీ మేజర్ విల్ బి ఎలక్ట్రోఫైల్ ఎట్ విచ్ పొజిషన్? ఎలక్ట్రోఫైల్ ఎట్ ద సెకండ్ పొజిషన్ ఈస్ మేజర్. ఎందుకు అంటే ఇక్కడ స్టీరిక్ క్రౌడ్ డ్యూ టు దిస్ వన్ రిపల్షన్ విల్ బి హ్యాపెండ్, సో దట్ ఇట్ విల్ బి లెస్ సబ్స్టిట్యూటెడ్. నౌ దీనికి CH3కి ఆర్థో పొజిషన్, మళ్ళా OCH3కి పారా పొజిషన్లో ఉంది కదా, దీనికి రిఫరెన్స్లా ఇదేంది ఆర్థో, దీనికి రిఫరెన్స్లా ఇదేంది పారా. సో అండ్ ఇక్కడ లెస్ స్టీరిక్ రౌట్, పారా ఈస్ మేజర్, ఇది మేజర్. ఓకేనా. నెక్స్ట్ ఇక్కడ ఇప్పుడు OCH3 ఇచ్చినాడు అండ్ CH3 ఇచ్చినాడు. ఇప్పుడు ఎలక్ట్రోఫైల్ ఎక్కడ అటాక్ అవుతుంది, నెంబరింగ్ ఇస్తాను నేను కార్బన్స్ 1 2 3 4 5. ఇప్పుడు ఎలక్ట్రోఫైల్ ఎక్కడ అటాక్ అవుతుంది, 1 కార్బనా 2 కార్బనా 3 కార్బనా 4 కార్బనా, 1 కార్బనా 2 కార్బనా 3 కార్బనా 4 కార్బనా, వేర్ ద ఎలక్ట్రోఫైల్ విల్ బి అటాక్డ్, 1 కార్బనా 2 కార్బనా 3 కార్బనా 4 కార్బన్. Now where the electrophile will be added, 1 carbon or 2 carbon or 3 carbon. ఎక్కడ అటాక్ అవుతుందమ్మా ఎలక్ట్రోఫైల్, ఎక్కడ అటాక్ అవుతుంది? నేను మేజర్ అడగడం లేదు, మేజరా మైనర్ అడగడం లేదు, ఎక్కడ అటాక్ అవుతుంది నేను మేజరా మైనర్ అని అడుగుతలేను. ఎక్కడ ఎలక్ట్రోఫైల్ అటాక్ అయ్యే ఛాన్స్, ఇక్కడ ఇందులో నేను మేజర్ ఎందుకు అడిగినా అంటే మనకి 2 ఛాన్సెస్ ఉన్నాయి, ఇక్కడ ఛాన్సెస్ ఉంది, ఇక్కడ కూడా ఛాన్స్ ఉంది. సో ఇది ఆర్తో ఇది పారా కదా, సో అందుకని పారా ఈస్ మేజర్ అన్న. కానీ ఇక్కడ ఒకటే సబ్స్టిట్యూయెంట్, 5 అన్న అటాక్ అయ్యచ్చు, 2 అన్న అటాక్, 5 అన్న అటాక్ అవ్వచ్చు, 2 అన్న అటాక్ అవ్వచ్చు, ఒకటే పొజిషన్ కదా అన్న. దీనికి ఇది ఆర్తో, దీనికి ఇది ఆర్తో, కానీ పారా పొజిషన్లో ఆల్రెడీ ఒక సబ్స్టిట్యూయెంట్ ఉంది, కాబట్టి దెర్ ఇస్ నో ఛాన్స్, అక్కడ ఛాన్స్ లేదు, ఇంకో ప్రోడక్ట్ ఇవ్వడానికి ఛాన్స్ లేదు. సో ఒకటే ప్రోడక్ట్, ఐదర్ 2 కెన్ అటాక్, ఐదర్ 5 కెన్ అటాక్. నానా ప్రణీత్ ఒక్కడే ఆన్సర్ ఇస్తున్నాడు, మీరు కూడా ఆన్సర్ ఇవ్వాలి. ట్రై టు ఆన్సర్ వెదర్ ఇట్ ఈస్ అ కరెక్ట్ ఆర్ రాంగ్. నెక్స్ట్ ఇప్పుడు ఎలక్ట్రాన్ ఒకటి డిఫరెంట్ ఎలక్ట్రాన్ రిలీజింగ్ గ్రూప్ తీసుకున్నాం. మరి ఇప్పుడు మనం సేమ్ తీసుకుందాం, ఒక CH3 ఇక్కడ ఒక CH3 తీసుకున్నాం. ఇప్పుడు 2 సేమ్ ఎలక్ట్రాన్ రిలీజింగ్ గ్రూప్సే. మరి ఇప్పుడు ఎలక్ట్రోఫైల్ ఎక్కడ యాడ్ అవుతుంది చెప్పండి? 1 ఇది 2 ఇది 3 ఇది 4, చెప్పండి ఎక్కడెక్కడ యాడ్ అవ్వచ్చు? ఎక్కడ యాడ్ అవ్వచ్చు? వేర్ ద కార్బన్ విల్ బి యాడెడ్. 5 and 2 ఎక్కడన్నా అటాక్ అవ్వచ్చు, 5లో అటాక్ అవ్వచ్చు, 2లో ఒకటి లాస్ట్ దాంట్లో. చెప్పండి. ఇప్పుడు సేమ్ ఎలక్ట్రాన్ రిలీజింగ్ గ్రూప్స్ ఇచ్చినాడు, సేమ్ ఉన్నాయి, ఎక్కడెక్కడ అటాక్ అవ్వచ్చు? 2 and 3. 2 and 3. ఈ 2 and 3లో ఎట్లా అటాక్ అవుతారన్నా? 2 and 3లో ఎట్లా అటాక్? 2లో అసలు అటాక్ అవ్వదు, 3 and 1లో అటాక్ అవుతుంది. 3 and 1 ఎందుకంటే ఇక్కడ ఇప్పుడు దీనికి 3 and 1లో కూడా అటాక్ అవుతారన్నా. ఇప్పుడు ఇక్కడ CH3కి ఈ CH3కి ఇది ఆర్తో, 3 ఓకే, ఈ CH3కి ఇది ఆర్తో, ఈ 1 CH3కి ఈ కార్బన్ ఆర్తో, మరి ఈ CH3కి ఇది ఆర్తో, మళ్ళా ఈ CH3కి ఇది పారా, క్లియర్? ఈ CH3కి ఇది మెటా, ఈ CH3కి ఇదేంటి పారా. మరి ఎట్లా అటాక్ చేద్దాం? హౌ కమ్ ఇట్ విల్ బి అటాక్డ్? ఇప్పుడు 1 కార్బన్లో ఎలక్ట్రోఫైల్ యాడ్ అయినా, ఈ 4 కార్బన్లో ఎలక్ట్రోఫైల్ యాడ్ అయినా సేమే. ఎట్లా సేమే? 1, 2, 3 ట్రైమిథైల్ బెంజీనే ఇస్తుంది. ఇప్పుడు 1 దగ్గర యాడ్ అయినా యూ కెన్ సీ ఇక్కడ ఎలక్ట్రోఫైల్ యాడ్ అయినా, అదే 1, 2, 3 వస్తుంది, 1, 2, 3 వస్తుంది. అదే మళ్ళీ నెక్స్ట్ ఎలక్ట్రోఫైల్కి ఛాన్స్ ఎక్కడ ఉంది? 3 పొజిషన్లో ఉంది. 3 పొజిషన్లో అటాక్ అయితే ఇక్కడ CH3, ఇక్కడ CH3 అంటే ఈ యొక్క హైడ్రోజన్ ఈ CH3కి ఒక రిఫరెన్స్ తోని ఇది ఆర్తో, ఈ CH3కి ఇది రిఫరెన్స్ తోని ఇది పారా. అంటే ఇక్కడ ఈ ఇక్కడ ఇక్కడ అటాక్ అయినా ఇక్కడ అటాక్ అయినా సేమే. ఎందుకు ఇది 1, 1, 2, 4 ఇక్కడ అటాక్ అయినా కూడా 1, 2, 4 కదా. సో ఇక్కడ 3 and 2 సేమ్, ఇక్కడ 1 and 4 సేమ్. ఓకేనా? వెన్ ఎవర్ ద 2 సేమ్ సబ్స్టిట్యూయెంట్స్ ఆర్ గివెన్, ఎప్పుడైనా 2 సేమ్ సబ్స్టిట్యూయెంట్లు ఆర్ సేమ్ ఎలక్ట్రాన్ డొనేటింగ్ గ్రూప్స్ ఇచ్చిండు అంటే దానికి 1, 4 సేమ్. ఎందుకంటే 1 పొజిషన్లో ఎలక్ట్రోఫైల్ యాడ్ అయినా మళ్ళా ఫోర్త్ పొజిషన్లో ఎలక్ట్రోఫైల్ యాడ్ అయినా ఇక్కడ ఎలక్ట్రోఫైల్ యాడ్ అయినా ఇది కూడా ఒకవేళ 1, 2, 3 అంటాం, ఇది కూడా 1, 2, 3 అంటాం. సో 1 and 4 పొజిషన్ సేమ్. మళ్ళా ఇక్కడ 2 and 3 పొజిషన్స్లో యాడ్ అయినా కూడా 1, 2, 4 అవుతుంది. 1, 2, 4 ఇక్కడ అటాక్ అయినా కూడా 1, 2, 4 అవుతుంది. సో క్లియర్ కదా? అంటే ఇక్కడ 1, 2, 3 అండ్ 1, 2, 4. ఇప్పుడు చెప్పండి ఆ రెండిట్లలో ఏది మేజర్? 1, 2, 3 సబ్స్టిట్యూయెంట్ మేజరా, 1, 2, 4 సబ్స్టిట్యూయెంట్ మేజరా? అంటే మీకు అర్థం కానట్టుంది, నేను మళ్ళీ ఒకసారి రాస్తా. ఇప్పుడు 2 సేమ్ ఎలక్ట్రాన్ రిలీజింగ్ గ్రూప్స్ ఇచ్చినాడు. దీనికి 2 ఛాన్సెస్ ఉంటాయి. ఒకటి ఇక్కడ CH3, ఇక్కడ CH3, ఇక్కడ ఎలక్ట్రోఫైల్. నెక్స్ట్ వన్ ఇక్కడ CH3, ఇక్కడ CH3, ఇక్కడ ఎలక్ట్రోఫైల్. ఓకేనా? నెక్స్ట్ సెకండ్ ఛాన్స్ ఫోర్త్ పొజిషన్లో ఇక్కడ CH3, ఇక్కడ CH3, ఇక్కడ ఎలక్ట్రోఫైల్. నౌ ద నెక్స్ట్ పొజిషన్, here the one CH3, here the one CH3 and here it is a electrophile. Now you see me, these 2 are 1, 2, 4 addition. Now these 3 are 1, 2, 3 addition. Among the 1 and 2 which is major? Major ఏది? 1, 2, 3 మేజరా, 1, 2, 4 మేజరా? 1, 2, 3 is major or 1, 2, 4 is major? Yes, 1, 2, 4 is major because here this is having the repulsion. 1, 2, 4 is major than the 1, 2, 3. 1, 2, 3 compared to the 1, 2, 3, 1, 2, 4 is major. Done? Now right. Next, if suppose one electron releasing group if they have given, one electron withdrawing group is given. Now second, same thing, one electron releasing group is given and electron withdrawing group is at ortho. Next, one electron releasing group is given and one electron withdrawing group is at ortho. Now you say me, now we have to decide the product on the basis of which one? Now the electron releasing group if they have given, clear? Now here the electron releasing group is there, electron withdrawing group is there. Now the electrophile will go on the basis of which one will increase the electron density at ortho and para only. It will be decided on the basis of only which will increase the electron density at ortho and para only. ఓకేనా? మనం ఎలక్ట్రాన్ రిలీజింగ్ సబ్స్టిట్యూయెంట్, ఇప్పుడు ఒకవేళ ఎలక్ట్రాన్ విత్డ్రాయింగ్ గ్రూప్ ఉన్నా ఒకవేళ ఎలక్ట్రాన్ రిలీజింగ్ గ్రూప్ ఉన్నా మనము రిఫరెన్స్ ఏది తీసుకోవాలి? ఎలక్ట్రాన్ ఏదైతే ఎలక్ట్రాన్ రిలీజ్ చేస్తుందో. ఇప్పుడు ఒకవేళ OH ఉంది నాన్న, ఒకవేళ ఇక్కడ OH ఉంది, ఇక్కడ ఒక ఆల్డిహైడ్ ఉంది అనుకుందాం. నౌ ఇక్కడ ఒక ఎలక్ట్రోఫైల్ ఉంది. నౌ ఇప్పుడు ఎలక్ట్రోఫైల్ ఎక్కడ అటాక్ అవుతుంది? 1 కార్బన్లో అటాక్ అవుతుందా, 2 కార్బన్లో అటాక్ అవుతుందా, 3 కార్బన్లో అటాక్ అవుతుందా, 4 కార్బన్లో అటాక్ అవుతుందా చెప్పండి. ఇక్కడ ఏ కార్బన్లో అటాక్ అవుతుంది, ఏది మేజర్? ఏ కార్బన్లో ఎలక్ట్రోఫైల్ అటాక్ అయితే మేజర్. దీనికి ఎలక్ట్రోఫైల్ 1 కార్బన్లో అటాక్ అవుతుందా, 2 కార్బన్లో అటాక్ అవుతుందా, 3 కార్బన్లో అటాక్ అవుతుందా, 4 కార్బన్లో అటాక్ అవుతుందా? 1 కార్బన్లో అటాక్ అయినది మేజరా, 2 కార్బన్లో అటాక్ అయినది మేజరా, 3 కార్బన్లో అటాక్ అయినది మేజరా? విచ్ వన్ ఈస్ మేజర్? 3 కార్బన్ మేజర్. ఎందుకు? రీజన్ చెప్పగలుగుతావా ప్రణీత్? కెన్ యూ సే మీ ద రీజన్? కెన్ యూ సే మీ ద రీజన్ వై యు ఆర్ సేయింగ్ ద 3? 3 మేజర్ అంటున్నావు, నాకు రీజన్ కావాలి. నువ్వు 3A ఎందుకు మెటా డైరెక్టింగ్? గుడ్, రైట్. ఫర్ ద aldehyde 3 is meta. For the OH it is para. Para directing to the alcohol. Good. Para directing to the alcohol. And the 3 is meta directing to the aldehyde. So the electrophile will be major here. Good. 3. One will be the OH and one will be the aldehyde. Okay, good. So the 3 is major. Why? Because here the OH, which one? This is a aldehyde. 3 is meta and the OH it is a para. And now you say me next one. If they have given, yes, good. It is, yes, no. Yes, it is para directing group. Good. Next, suppose if they have given here it is a OH and here it is a, and the meta position, if they have given the any withdrawing group NO2. Now you say me electrophile will go and attack at the which position? Now the electrophile will go and attack at the which position? Electrophile will go and attack to the which position? Electrophile will go and attack to the which position? Now 1 carbon is major, 2 carbon is major, 3 carbon is major, or 4 carbon is major? Where it will be attacked? 1 carbon it will attack, 2 carbon it will attack, 4 carbon it will attack, 3 carbon it will attack. Where it will be attacked? 1 carbon it will be attacked, or 1 carbon it will attack, 4 carbon it will attack, 3 or 3? 3 4 or 3, not sure. చూడు నేను ఏం చెప్పినా, వాట్ ఐ సెడ్, ఇఫ్ ఎనీ 3 కార్బన్ కాదు. ఇప్పుడు 3 కార్బన్లో సి వాట్ ఐ సెడ్, ఇఫ్ ఎనీ ఎలక్ట్రాన్ రిలీజింగ్ గ్రూప్ and electron withdrawing group if are attached, we have to check on the basis of one will release the electrons very fastly on the ortho and para directing group అనగా. ఏదైతే ఎలక్ట్రాన్లు తొందరగా ఆర్థో పారా డైరెక్టింగ్ చేస్తుందో అక్కడనే మనం ఎలక్ట్రోఫైల్ యాడ్ చేయాలి. మరి 3 కార్బన్లో ఎలక్ట్రోఫైల్ యాడ్ అయితే మరి ఓహెచ్కి అది మెటా డైరెక్టింగ్ అనడా? ఓహెచ్కి అది మెటా డైరెక్టింగ్, అక్కడ అవ్వడానికి ఛాన్స్ లేదు. అయితే 4, ఓకే 4లో ఛాన్స్ ఉంది. ఓకే 4లో ఛాన్స్ ఉంది. నెక్స్ట్ ఇంకెక్కడ ఛాన్స్ ఉంది? 4లో ఛాన్స్ ఉంది, 1లో ఛాన్స్ ఉంది, 2లో కూడా ఛాన్స్ ఉంది. మరి ఇక్కడ ఏది మేజర్? 4 అటాక్డ్ ఎలక్ట్రోఫైల్ మేజరా, 2 అటాక్డ్ ఎలక్ట్రోఫైల్ మేజరా, 1 అటాక్డ్ ఎలక్ట్రోఫైల్ మేజరా? 2 అటాక్డ్ ఎలక్ట్రోఫైల్ ఈస్ మేజర్, బికాస్ హియర్ ఇక్కడ bulky due to the repulsion it is less stable and the 2 attacked electrophile is major. 4 is nearer to the yes, 4 attacked electrophile is major. Okay na? Clear? Done. Ippudu clear? Now we have seen when they have given the what? 1 electron releasing group and the 1 electron withdrawing group if it is such. If two are attached now, Now 2 are attached to the two electron withdrawing groups are attached. If the 2 electron withdrawing groups are attached, now the electrophile will go and attack to the which position? Which carbon? 1 carbon, 2 carbon, 3 carbon or 4 carbon? Now you see me. Now here the electrophile will go and attack to the 1 carbon, 2 carbon, 3 carbon or 4 carbon. Same. In the 1 where the electrophile will be added, in the 2 where the electrophile will be added. 2 and 4. 2 is major. Yes, good. Because among the 2 electron withdrawing groups, you have to attack to that one which will provide the strong electron withdrawing one. If the 2 electron withdrawing groups, if they are given, among those 2, which is the strong electron withdrawing group, according to that one only we have to add. According to that one only we have to add. So 2 is major. Now in the second one case, same for second compound. Same for second compound. Second compound ki same. Second compound ki ekkada attack aitadi? 2 lo attack aitada. Second compound the 2 is major because both the cases it is betting meta position only. Ikkada NO2 ki idi meta ne, aldehyde kuda idi meta ne. Both the cases it is getting meta. Okay, good. మరి ఇప్పుడు ఒకవేళ ఇప్పుడు ఆల్డిహైడ్ ఇక్కడ NO2 ఇక్కడ. నవ్ యూ సే మీ ఇప్పుడు ఎక్కడ అటాక్ అవుతుంది? 1 2 3 4. ఇప్పుడు ఎక్కడ అటాక్ అవుతుంది? ఎలక్ట్రోఫైల్ వేర్ ఇట్ విల్ బి యాడెడ్? ఎలక్ట్రోఫైల్ ఎక్కడ యాడ్ అవుతుంది? 3 and 4. గుడ్. 3 and 4. ఓకే. 3 and 4. Okay, fine. If suppose ఇట్లా ఇచ్చినాడు కాంపౌండ్, ఇప్పుడు ఎలక్ట్రోఫైల్ ఎక్కడ అటాక్ అయితే మేజర్? ఇది రింగ్ నెంబర్ 1, ఇది రింగ్ నెంబర్ 2. రింగ్ నెంబర్ 1, రింగ్ నెంబర్ 2. ఎలక్ట్రోఫైల్ ఎక్కడ అటాక్ అయితే మేజర్? ఎక్కడ అటాక్ అయితే మేజర్? వేర్ ద ఎలక్ట్రోఫైల్ అటాక్డ్ విల్ బికమ్ మేజర్. ఎక్కడ అటాక్ అయితే మేజర్? ఇట్లా ఇచ్చినాడు. ఇప్పుడు ఎలక్ట్రోఫైల్ రింగ్ నెంబర్ 1 కార్బన్ అటాక్ అవుతుందా, రింగ్ నెంబర్ 2 కార్బన్ అటాక్ అవుతుందా? సార్ దిస్ క్వశ్చన్ ఐ హ్యావ్ డౌట్. అదే ఐ విల్ ఎక్స్ప్లెయిన్ యూ, ఐ విల్ క్లియర్ యువర్ డౌట్. నువ్వు ట్రై చేయి 2 కాదు. No, it will attack to the 1 number carbon electrophile will be added. ఎందుకు నేను ఏం చెప్పినా, whenever the 1 electron withdrawing group and 1 electron releasing group, if it is attached, now this is a compound. Now you see here, this is a ortho para directing group. It will increase the electron density at ortho and para positions. And this is a electron withdrawing group. It will decrease the electron density at ortho and para. Now we are doing the electrophilic addition. Electrophilic addition we require the more electron density. Clear? More electron density. Then it will go to the ring number 1, not the ring number 2. Electrophile will go and attack to the ring number 1 para position, because at the ortho position it will be repel. So the para position 1 will be the major. If they ask where the possible reactions, if they ask, now ring number 1 ortho and para directing groups is possible, because this is meta directing group. Meta directing group, it will be decrease the electron density at which one, and in comparison with the electron releasing one and in comparison with the electron withdrawing one, we will take the high priority for the electron releasing only, right? Here we have seen. ఇప్పుడు ఇక్కడ చూసినాం కదా, ఇది కాదు, not this one, not this one. If one electron withdrawing and electron releasing group and the electron withdrawing group is present, electron releasing group is high priority than the electron withdrawing group priority order, right? So that's the reason only we have to cross check on the basis of which one will release the electron density. On that basis only we have to add. Clear అయిపోయిందా? డౌట్ క్లియరా? ఇంకొక క్వశ్చన్ ఏనా? ఇంకొక క్వశ్చన్ ఏనా? రైట్. This is 1, this is 2. Now electrophile will go and attack to the 1 number phenyl or 2 number phenyl. This is question number 1. Question number 2. Here it is 1, here it is 2. Chep. Now same. In the first one, electrophile will go and attack to the 1 number phenyl or 2 number phenyl. Now in the second one, electrophile will go and attack to the 1 number phenyl or 2 number phenyl. First question 2. Chandrapranit, you are saying first question 2. First question ki 2 number. First question you are saying it will go and attack to the 2. Second one 1. Good, because here the nitrogen lone pair of electrons, due to that electrophile will go and attack to 2 number benzene ring. In the second question you can see already this phenyl is attacked to the more electronegative sp2 carbon. More electronegative sp2 carbon which is attached. Now here the nitrogen, it is having the lone pair of electron. This will release to the this 1 number phenyl and the electrophile will go and attack to the 1 number carbon. Clear? In the first one case, electrophile will go and attack to the 2 number carbon, and in the second one case, electrophile will go and attack to the 1 number carbon. Clear in the? Any confusion still? Right. Done. Next, first reaction of the benzene, that is halogenation. Halogenation lo benzene plus X2 in the presence of FeX3. Direct రాస్తున్నానా, నేనేం మెకానిజంకి ఏం వెళ్ళడం లేదు, డైరెక్ట్ రాస్తున్నా. ఆల్రెడీ యు నో. ఓకేనా? ఇక్కడ ఏదైనా Cl2 తీసుకుంటే విల్ గెట్ ద క్లోరోబెంజీన్, ఏదైనా Br2 తీసుకుంటే విల్ గెట్ ద బ్రోమోబెంజీన్. ఓకేనా? రియేజెంట్ సేమ్. Done. ఇది అబౌట్ ద రియాక్షన్. నెక్స్ట్ విల్ డూ ద రియాక్షన్ ఫర్ దిస్ వన్. ఇప్పుడు టౌలిన్ ఇచ్చినండి అన్న. టౌలిన్ అంటే ఇదే. ఇప్పుడు సిఎక్స్, ఇది టౌలిన్ కదా, దిస్ ఈస్ ద టౌలిన్. టౌలిన్కి ఇప్పుడు సపోజ్ Br2 Fe Br3 ఇచ్చినాడు ఒక రియాక్షన్. నార్మల్గా Br2 H nu ఇచ్చినాడు. నెక్స్ట్ NBS CCl4 ఇచ్చినాడు, NBS CCl4 ఇచ్చినాడు. ఇక్కడ చెప్పండి ఏ ఏంటిది, బి ఏంటిది, సి ఏంటిది? ఏ ఏంటిది, బి ఏంటిది, సి ఏంటిది? What is the A over there? What is the B over there? What is the A over there? What is the B over there? What is the A over there? What is the B over there? What is the C over there? మనం తొందరగా మీరు కంప్లీట్ చేస్తే క్వశ్చన్ స్టార్ట్ చేయొచ్చు నాన్న. మీరు తొందరగా ఆన్సర్ మీకు ఆన్సర్ తెలిస్తే ఆన్సర్ తెలుసు అని చెప్పండి, లేకపోతే క్వశ్చన్ మార్క్ ఇవ్వండి. మీరు తొందరగా ఫినిష్ చేస్తే వీ కెన్ మూవ్ టు ద క్వశ్చన్ సెక్షన్. మనం క్వశ్చన్ సెక్షన్కి వెళ్ళిపోవచ్చు తొందరగా, లేకపోతే మళ్ళీ అది రేపటికి పోస్ట్పోన్ అవుతుంది. Anyone in the live? Two bromo, one methyl benzene. 2 bromo, 1 methyl benzene for the first one. 2 bromo, 1 methyl benzene. 2 bromo toluene. Okay, fine. Okay. ఇక్కడ బ్రోమో ఆర్థో పొజిషన్లో ఒకటి, పారా పొజిషన్లో ఒకటి వస్తుంది. ఓకే, క్లియర్, డన్. దాని తర్వాత నెక్స్ట్ వన్, సెకండ్ వన్. దిస్ ఈజ్ అ free radical substitution reaction. Clear? Now this is the NBS, we know allylic position. Now hydrogen it will be replaced, allylic position the hydrogen it will be replaced, and both the B and benzyl bromide will get. Both is same. 4 bromo 1 methyl benzene. What 4 bromo? That is correct. Okay, done. Now both the cases, free radical substitution reaction and the NBS, both will give you the same. And next one, and the next type of the reaction we are going to see, that is nitration. Okay, next reaction we are going to see nitration we are going to see. In the nitration, what it will be there? In the nitration, benzene in the presence of what? Concentrated H2SO4 and HNO3. Now at a slow and 60 degrees Celsius, what it will give? It will give the NO2 as a electrophile. Done. Here we know this is a acid, and this is a base, Bronsted. This is Bronsted acid. Now this is a Bronsted base, and it will give the nitrobenzene. Okay, now a mechanism I was not going. Now try to predict the answer. If suppose if they have given one NO2 if they have given HNO3 plus concentrated H2SO4, if they have given HNO3 and the concentrated H2SO4, if they have given, then what are the products we will get? And if the CH3 if they have given, and a concentrated H2SO4 and dilute H2SO4 and 2 moles of dilute HNO3 and 2 moles of H2SO4. संजीव शर्मा, नीट का रिजल्ट आया है आज. meta position number 2. Okay, meta position number 2. Cut. Now Sanjeev Sharma, I was very much poor in reading the Hindi. So for that one, I may not help you for that one. Better if you have texted me in the English, I can give you any suggestion or anything. Sanju Sharma, if you have written that whatever the text you have given to me, that you have given me in the Hindi, it is more difficulty for me to read the Hindi. NEET की रिजल्ट आया है आज, कुछ ना पहले, something you are written. It is very difficult for me. Okay, now in this case, one it will be the meta position, one it will be at the meta position, and one will be at the, here in this case toluene if they are given, here the NO2, here the NO2, and here it will be the NO2. Done. Nana, the one who is in the live, మీకు సల్ఫోనేషన్, ఫ్రిడెరిక్ ఆల్కైలేషన్, అసైలేషన్ అవి క్లియర్ ఉన్నాయి కదా. క్వశ్చన్ స్టార్ట్ చేయను అన్న, మీకు అవి క్లియర్ ఉన్నాయి అంటే క్వశ్చన్ స్టార్ట్ చేస్తా. మళ్ళా ఇవే ఊరికే ఇవే రియాక్షన్లు చదివితే టైం వేస్ట్. క్వశ్చన్లు స్టార్ట్ చేయనా? షుడ్ ఐ స్టార్ట్ ద క్వశ్చన్స్? మీకు అవి సార్ మాకు అవి క్లియర్ ఉన్నాయి సార్, మాకు అన్ని క్లియర్ ఉన్నాయి సార్, మాకు ఏం అవసరం లేదు, క్వశ్చన్ స్టార్ట్ చేయనా? ఎవ్రీవన్, ద వన్ హూ ఈస్ ప్రజెంట్ ఇన్ లైవ్, అందరూ మీరు క్వశ్చన్ స్టార్ట్ చేయమంటే నేను క్వశ్చన్ స్టార్ట్ చేస్తా. రైట్, ఓకే, రైట్ 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 రైట్. నార్మల్ క్వశ్చన్సా కన్వర్షన్ క్వశ్చన్సా? రెండు, కన్వర్షన్స్ కమ్ నార్మల్. ఓకేనా? కొన్ని మనం కన్వర్షన్ క్వశ్చన్ చూద్దాం, కొన్ని నార్మల్ క్వశ్చన్స్ కూడా చూద్దాం. రైట్, ఫస్ట్ వన్. Now, first one, first question. First question. Alkylic KOH. Priyanshu, okay, fine Priyanshu, I can use the English. Okay, I can use in the English. Fine, I can use the English, no problem. Now I will write the questions. Now try to predict the answer for it. Okay Priyanshu, okay, fine. Now try to predict the answer for the given questions. Try to predict the answer for the given questions. Now here they have given the, which one? Alkali chloride upon alcoholic KOH eating, then butadiene. Now okay, no Priyanshu, fine. Now second. Now this one, what is the product? 2-fluorobutane upon alcoholic KOH. 2-fluorobutane upon alcoholic KOH. Butane upon alcoholic KOH. Butane upon alcoholic KOH. What is the product? Butadiene. Which mechanism it is following? May I know in the second one which mechanism it is following? May I know in which mechanism it is following? E1CB. Good Nana. Good. E1CB. I thinking అది కరెక్టే, అది కరెక్ట్ ఓన్లీ ఈవెన్ సిబి. ఎఫ్ ఈజ్ అ బ్యాడ్ లీవింగ్ గ్రూప్. గుడ్, రైట్. థర్డ్ క్వశ్చన్. Right now, which among the following is correct? Now you have to say me. Now you say me, among the 1, 2, 3, 4, which is a major, which is a major product, which is a major product? B. Why not A? Why not A? Why you are saying it as a B? Why not A? Br and H are not in trans. Good, 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 good. Because already this is a CH3. Now whatever the hydrogen it is there, it is a cis to each other. Then when it is a cis to each other, now the here readily this OH minus will not take in the, whenever the stereochemistry questions, this type of the questions if they are asking. So you have to be very careful. Now here the one trans hydrogen will be there. Now this trans hydrogen, this OH will be readily abstract and the Br will be eliminated. So the option number B is correct. Option number B is correct. Done. Now next. Next. Now next one we are having here the stereochemistry of this Cl and the stereochemistry of this Br, and again here we are having the one bulky group and a alcoholic KOH heating. Now what is the answer we will get? Now this is a A. Now B. This is a B. Now C. Now D. None of the above. Now what is the answer for this one? What is the answer for this one? What is the answer for this one? None of the above na. None of the above కాదు నానా. ఆన్సర్ ఉంది, ఆన్సర్ ఉంది, ఆన్సర్ ఈస్ దేర్. ఆన్సర్ అయితే ఉంది. ఆన్సర్ ఈస్ దేర్. ఏనా? ఏ కాదు, ఏ కాదు, Now listen. Here you are thinking that here this type of the questions if they have given, you are saying that answer is A. How come alkane will form? I was not given any another mole, right? If I was given the 2 moles, then alkyne will form. If I was given this as a 2 moles, alkyne will form. But here I was not provided any alkyne. Sorry, I was not provided any 2 moles. I was provided only 1 mole. Now you see, actually the answer is B, not the A. Actually the answer is B, not the A. Now why? Because, now listen. Here, if suppose, here the Cl they have given. Now here the Br they have given. Done. Here the bulky group. Now if suppose this alcoholic KOH, if the hydrogen, if it is eliminated from here. Now here you may thought that Br is a good leaving group, it will be eliminated, you have thought. But here, if the ikkada trans hydrogen undi, here the trans hydrogen it is there. If this base readily abstracted this trans hydrogen and the Cl will be eliminated, then the product we will get. In this manner the product we will get, and here it will be the Br. Then for this alkene you can see, for this alkene it is having the 4 alpha hydrogens. Done. Then if suppose, if this base, if it is readily abstracted this proton and if it is eliminated and this is Cl, then what is the product it will get? In this manner it will get. Now here it will be the Cl. Then you can cross check here for this one. Here also it is having the 2 alpha hydrogens. Here also it is having the 2 alpha hydrogens. Here, sorry. For this one also it is having the 2 alpha hydrogens. Then how to cross check? Here which one will be the more major? ఇప్పుడు రెండిట్లలో bromine and the chlorine, then which one will be readily reacted? Which one will be the readily reacted with the, ఇక్కడ bromine కి 4 alpha hydrogens వస్తున్నాయి, ఇక్కడ కూడా bromine is equatorial sir, both are. Which one is equatorial? Bulky group should be equatorial, is more stable. Bulky group that is containing at equatorial position is more stable. So the one which is in the axial position, it will be eliminated. Yes, bulky group containing at the equatorial position, it is more major. Compared to the Cl and the Br is a more bulky, right? Bulky group, it will not be react very fastly. So the Cl at the axial position, it will be react and it will be eliminated. Bulky group equatorial. Good. Yes, due to the bulky group and the equatorial, it is eliminating. Okay. Now, next type of the question. CH3, Br, H, now Br, H, now CH3 in the presence of sodium iodide acetone. Can you say me the answer? Can you say me the answer? Can anyone say me the answer? Can anyone say the answer? Okay. Now, next one, CH3. తెలిస్తే ఆన్సర్ చెప్పండి, తెలియకపోతే ఓకే ఫైన్. Br and this is a H and this is a ethyl, and if they have given the sodium iodide in the form of acetone. Okay. Now in the sodium acetone, if suppose any meso compound, if they have given meso upon sodium NaI in the presence of acetone, readily it will give the alkene. readily it will give you the alkene. Meso upon the Ni-acetone, if you have seen, it will give you the alkene. And if suppose unsymmetrical, you can see unsymmetrical, this is unsymmetrical and this is a opposite to each other, right? Now this is a one erythrotype, it is there, right? Now this upon the NaI, what it will give? It will give you the cis. It will give you the cis type product it will give. This you have to be very careful. Meso upon NaI acetone trans it will give. Erythrotype upon sodium iodide upon acetone, what it will give? Cis it will give. Clear? Cis it will give. Next one will move. Next one will move to the next question. I will write some products. Which one will readily undergoes dehydration reactions? You have to say me. Which one will readily undergo dehydration reaction fastly? Dehydration reaction fastly. Now among the 1, 2, 3, 4, which one will readily undergo dehydration reaction very fastly? Which one will readily undergo dehydration reaction very fastly? Hey, dehydration reaction, what is the intermediate? Dehydration reaction, what is the intermediate? In the dehydration reaction, what is the intermediate? Benzyl carbocation. That phenyl carbocation is unstable. Not benzyl, phenyl. This is benzyl. This is benzyl carbocation. This is a benzyl carbocation. Here this is a phenyl carbocation. This is a phenyl carbocation. Option 3. 3. Next after the 3. After the 3, what is the answer? After the 3. 3, 2, 4, 1 is the answer. 3, 2, 4, 1 is the answer. Clear? Now, next. Now, difference between 2 and 4. Here it is giving the 2 degree carbocation, right? 2 degree carbocation. Here it is generating 1 degree carbocation. If the OH, if it is eliminated from here, it is generating 1 degree carbocation. If the OH is eliminated from here, it is producing 2 degree carbocation. It is producing the 3 degree carbocation. 3 degree carbocation is more, 2 degree, 1 degree and a normal phenyl carbocation. That's it. Next. Now, H plus upon heating. Now, what is the product name? What is the product name? Product IUPAC name. What is the product we will get? What is the product we will get? What is the product we will get? You know? What is the product we will get here? If you know, say me, sir, double bond. Double bond ekkada? Between the ring. Double bond between the ring. That double bond between the ring, 5-membered ring or 6-membered ring. And rings are 5-membered, comma 6 or 6, comma 6 or 6, comma 5. No. Which in between double bond is between 5, comma 6 ring or 6, comma 6 ring or 6, comma 5 ring. Between which one? Sir, both are 5-membered rings. No. Listen. మీకు మీరు కన్ఫ్యూజ్ అవుతున్నారు ఎక్కడనో. Here this oxygen lone pair of electron, no, not between the 5 and 6. ఇక్కడ 5-membered ring ఇస్తే ఇక్కడ ఈ కార్బన్ కి ఇక్కడ పాజిటివ్ చార్జ్ వస్తుంది కదా. Now this carbon positive charge, if it is getting, now this bond will be shifted here. Here this carbon will get positive charge, here it will get negative charge, and the ring expansion will be happen. Here the ring expansion will be happen. Now the ring expansion will be happen 1, 2, 3, 4, 5 and 6. Now one 6-member carbon you write. After the 6-member carbon, now again we are having the 5-membered carbon in this manner. Done. Here the 2-number carbon, here having the positive charge. Again this 2-number carbon to stabilize, again this bond will be shifted here. Again you will get the carbocation here. Again this 2 will form the bond. Again this 2 will form the bond. When again this 2 has formed the bond, now what we will get? We will get the, in this manner, 6-membered rings. And here we will get the positive charge. Now hydrogen upon heating, right? Here we are having the hydrogen and we will get the, in this manner. 2 times of the ring expansion will be happened and the double bond will be between the 2 6-membered carbons. 2 6-membered carbons మధ్యలో డబుల్ బాండ్ ఉంటుంది. అర్థమైందా? Is it clear? Clear? Still any confusion? This is the product. దాన్ని క్రాస్ చెక్ చేసుకోవాలి. We have to cross check. ఓకే. ఇప్పుడు ఒక కన్వర్షన్ క్వశ్చన్ ఇస్తా. ట్రై టు సాల్వ్ ఇట్. ఫస్ట్ 1 CH3 in the presence of SO2 Cl2 or RO2 in the presence of H nu, it is giving A. A upon sodium, it gives B. Okay, this A upon zinc, it gives C. C upon Grignard reagent gives D. D upon D2O gives D. D upon NBS 1 equivalent H nu gives E major. major. This major upon sodium gives F. F upon 1 equivalent NBS gives G. G upon alcoholic KOH gives H. ఓకేనా? ఈ కన్వర్షన్ మీరు రాసుకోండి. రైట్ ఇట్ ఇన్ యువర్ బుక్ అండ్ షో మీ ఇట్ ఇన్ ద మండే, లేదంటే ట్రై టు టెక్స్ట్ మీ. నాకు ఆన్సర్ నాకు పర్సనల్గా టెక్స్ట్ చేయండి. టెక్స్ట్ మీ యువర్ ఆన్సర్ పర్సనల్లీ టు మీ. తెలిస్తే చెప్పండి, తెలియకపోతే నేను చెప్తా. తెలిస్తే చెప్పండి, తెలియకపోతే నేను చెప్తా. ఓకే, మీకు అంత ప్రాబ్లం అయితే సోడియం డ్రై ఈథర్ ఇస్తా. ఇది సోడియం డ్రై ఈథర్ ఇస్తా. సోడియం డ్రై ఈథర్. Now what it will get? ఏదన్నా ఫస్ట్ ప్రోడక్ట్ ప్రిడిక్ట్ చేయడానికి ట్రై చేయండి. ఇప్పుడు లిజన్ అన్న ఒక్కటే గుర్తుపెట్టుకోండి, ఇట్లాంటి కన్వర్షన్ క్వశ్చన్స్ ఇస్తే ఇప్పుడు మనకి ఇక్కడ ఆల్కాలిక్ KOH ఇచ్చింది కదా, బ్లైండ్లీ బిలీవ్ మనం ఏం ఫైండ్ చేయాలి? లాస్ట్ ప్రోడక్ట్ H ఆల్కైన్ అయి ఉండాలి. నేను చెప్తానండి. ఇప్పుడు ఆల్కాలిక్ KOH హీట్ మనకు తెలుసు, ఆల్కాలిక్ KOH హీట్ లాస్ట్ ప్రోడక్ట్ ఆల్కిన్ ఉండాలి. మనకి ఇక్కడ గ్రిగ్నార్డ్ రియేజెంట్ ఉంది, మనకి ఇక్కడ SOCl2 ఉంది, SO2Cl2 ఉంది. అదేం లేదు, అదేం చేస్తుంది అంటే ఇక్కడ Cl2 తీసి ఫస్ట్ బెంజైల్ క్లోరైడ్ చేస్తుంది. ఇట్లా ఇట్ విల్ సే ఇట్ ఫస్ట్ వన్ ఇస్ అ బెంజైల్ క్లోరైడ్ అపాన్ సోడియం డ్రై ఈథర్. విచ్ రియాక్షన్ ఇట్ ఈస్? సోడియం బెంజైల్ క్లోరైడ్ అపాన్ సోడియం డ్రై ఈథర్. విచ్ రియాక్షన్ ఇది? విచ్ రియాక్షన్ ఇట్ ఈస్? వస్తే చేయండి, నేనేమంటున్నా, వస్తే చేయండి, మీరు ట్రై చేయండి. నేను మండే రోజు నేను చెప్తా. వుడ్స్ రియాక్షన్. మరి వుడ్స్ రియాక్షన్ అయినప్పుడు అప్పుడు ఏమవుతుంది? అక్కడ వుడ్స్ రియాక్షన్తో ఏమవుతుంది? వుడ్స్ రియాక్షన్ అంటే 2 moles ఆఫ్ ఆల్కలీ యాలైడ్ కన్సిడర్ చేసుకోవాలి కదా. 2 moles ఆఫ్ ఆల్కలీ యాలైడ్ కన్సిడర్ చేసుకొని RR విల్ బి, అదే ఫినైల్ విల్ బి ఫార్మడ్. నెక్స్ట్ చాలా టైం అయింది అనుకుంటా. ఇంకొన్ని క్వశ్చన్స్ నేనేం చేస్తా తెలుసా, రేపు ఏ టైంకి ఫ్రీ ఉంటారన్నా మీరు? టుమారో ఎట్ వాట్ టైమ్ యూ విల్ బి ఫ్రీ? ఇక్కడికి ఎండ్ చేస్తా ఇది. రేపు ఓన్లీ క్వశ్చన్సే చేద్దాం. ఓన్లీ క్వశ్చన్స్ విల్ డూ కంప్లీట్ GOC అండ్ హైడ్రోకార్బన్ కంప్లీట్. I mean it will be become practice for your tomorrow's exam. I mean Monday's exam, whatever the Monday's exam you are having, that GOC and hydrocarbon completely I will make it now. నేను క్వశ్చన్స్ వన్ బై చేద్దాం అనుకున్నా కానీ నాకు టైం దొరకలే. సో రేపు చేస్తా. మీరు ఏ టైంకి ఫ్రీ ఉంటారో చెప్తే అది మీకు ఈవినింగ్ ఆల్ విల్ బి ఫ్రీ. ఆ టైం మీకు రేపటి ఎగ్జామ్కి, మండే ఎగ్జామ్కి ఫ్రీ అయిపోతుంది. మండే ఎగ్జామ్కి డైరెక్ట్ వెళ్ళి రాయొచ్చు. మండే ఎగ్జామ్ ఈజ్ ఎవ్రీథింగ్. మండే ఎగ్జామ్ ఈజ్ వెరీ ఈజీ. 4 or 5 సరే, బిట్వీన్ 5 or 6, in between 5 or 6 ఓన్లీ క్వశ్చన్స్. కంప్లీట్ GOC, ఓకే, కంప్లీట్ GOC అండ్ హైడ్రోకార్బన్స్. మీరు మార్నింగ్ మ్యాథ్స్ అండ్ ఫిజిక్స్ కంప్లీట్ చేసి పెట్టుకోండి. ఈవినింగ్ ఓన్లీ కెమిస్ట్రీ, ఓన్లీగా అది జస్ట్ ఎగ్జామ్కే మన ప్రిపరేషన్ లెక్క. సరేనా? కంప్లీట్ క్వశ్చన్స్ చేద్దాం రేపు. ఓన్లీ GOC అండ్ హైడ్రోకార్బన్ కంప్లీట్ క్వశ్చన్స్. నౌ ఐ వాస్ ఎండింగ్ ద క్లాస్ ఇయర్. సరేనా? రేపు ఈవినింగ్ నేను గ్రూప్లో ఇంటిమేట్ చేస్తా వాట్ ఈస్ ద టైం. లేదంటే ఐ విల్ షెడ్యూల్ ద లైవ్ ఇన్ మై ఛానల్. యూ కెన్ క్రాస్ చెక్ ద టైమ్ ఓవర్ దేర్. tomorrow I will schedule the live in the channel. The one who are in the live, they can cross check the live timings over there. Okay, sarena. We'll stop the class here. We'll meet tomorrow. రేపు 4 or 5 or 6 5 వరకు పెట్టేసుకుందాం. 5 వరకు లైవ్ పెడతాం. ఓకే రైట్. రేపు మార్నింగ్ వరకు మ్యాథ్స్ ఫిజిక్స్ కంప్లీట్ చేసి పెట్టుకోండి. మ్యాథ్స్ అండ్ ఫిజిక్స్ ట్రై టు కంప్లీట్. ఓకే నాన్న, బాయ్. గుడ్ నైట్.